1,000 meters down where no light has ever reached, something is moving. It is one of the largest animals that has ever lived, and for almost all of human history, no one had seen it breathe. And yet the ocean kept handing us the evidence. A beak in a whale's belly, a torn arm on a beach, a shape in the dark that vanished before the eye could hold it. We built a monster out of the pieces. We called it the kraken. We were wrong about the size, wrong about the shape, wrong about nearly everything except the one thing that matters. It is real. It is down there right now. And this is the animal itself, told the way the ocean actually made it. For centuries, the giant squid existed only as a body, never a living animal. Only the aftermath, a carcass rolling in the surf, a limb tangled in a fishing net, a mass of pale flesh going soft on the sand before anyone could reach it. Sailors found them. Fishermen hauled them up by accident. And every account began the same way, with something already dead. Think about what that means. An animal this enormous, and for most of recorded history, humanity knew it the way a detective knows a stranger, only from the outline left behind. No behavior, no movement, no hunt, just the corpse. The problem was the realm it lived in. The giant squid does not come to us. It stays down in the deep dark, in cold and crushing pressure, in a place the human body cannot follow. So the bodies came to us instead, one at a time, over hundreds of years, and each one raised more questions than it answered. Scientists could measure the arms. They could weigh the mantle. They could pull the great parrot beak from the center of the limbs and hold it in one hand. What they could not do was watch it live. And so, the science of the giant squid was for a very long time the science of the dead, a portrait assembled from remains guessed at, argued over, never confirmed by a single living glance. The monster was documented, it was just never observed. Long before science, there was the kraken. Nordic sailors told of it first, a sea beast so vast it could be mistaken for an island rising beneath a ship, dragging the whole vessel under with its arms. The stories spread across the northern waters for generations, a creature that surfaced without warning, a whirlpool where it sank. Fishermen who swore they had felt something move beneath the hull. Strip the legend down, and a real animal is standing inside it. The kraken was almost certainly built from glimpses of the giant squid, its long limbs breaking the surface, its bulk, the sheer wrongness of its shape to a human eye. A sailor sees a wet arm as thick as a mast slide back into the water. He does not think times cephalopod. He thinks times monster. And he tells the story on shore, and the story grows. Here is the strange part. The myth exaggerated the size, invented the island, added the malice, and still landed close to something true. There really is an enormous, many-armed animal in the deep ocean. It really can grow to lengths that stagger the mind. The legend got the temperament wrong. The giant squid is no ship killer. But it got the existence right, centuries before anyone could prove it. That is the tension this whole story lives in, the gap between what we imagined and what is actually down there. For most of human history, the kraken was all we had, a placeholder, a shadow standing in for an animal we could not yet reach. The reality when it finally arrived would be stranger than the myth, and harder to believe. The first real proof did not wash up on a beach. It came out of a whale. Sperm whales dive deep, far deeper than any human, and down there in the dark they hunt. When whalers began cutting into their stomachs, they found something they could not explain at first. Beaks. Hard, black, curved like a parrot's, by the hundreds and sometimes the thousands packed into a single whale's gut. The flesh of a squid digests. The beak does not. It is made of tough chitin, and it survives the stomach the way a stone survives a river. So each beak was a receipt, evidence that this whale had somewhere in the crushing deep seized and swallowed a giant squid. Count the beaks and the math turns astonishing. A single sperm whale might carry the remains of dozens of squid in its belly at once. Multiply that across a population of whales, across an ocean, across a year, and you arrive at a number that cannot be avoided. The deep is times, full times of them. There must be a staggering biomass of giant squid down there, far more than the rare corpse on the sand ever suggested. Pull one of those beaks from a whale's stomach and hold it in your palm, cold, hard, sharp at the tip, heavier than it looks. You are holding the only part of the animal that refused to disappear. This was the first hard clue that the giant squid was not rare, not a freak, not a one-off wonder. It was abundant. Common enough to be a staple in the diet of the largest predator with teeth on Earth. We just could not see it. Here is the paradox at the center of everything. The giant squid is one of the biggest animals on the planet, and until the 21st century, no human being had ever seen a healthy one alive. Sit with how unlikely that is. We had mapped the surface of the moon. We had photographed the bottom of the deepest trench. We had named and filmed creatures smaller than a grain of rice. But an animal that stretches longer than a city bus, that one stayed hidden. Not for years. For all of recorded history. The reason is simple, and it is the whole story of the deep. The giant squid lives where we do not go. Down past the reach of sunlight and water, near freezing under pressure that would crush a steel hull. It does not come up. It does not linger where cameras can find it. and it seems to flee the very machines we send down our lights, our engines, our noise. The deep-sea submersibles that finally reached its world may have been scaring it out of frame for decades without anyone knowing. So we had corpses, we had beaks, we had legends. We had everything except the one thing that would settle it, a living animal in its own world, going about the business of being alive. From above, from the deck of a research ship, the ocean gives away nothing. Flat, dark, silent. And somewhere beneath that surface, in numbers we still cannot count, an enormous predator moves through water no eye has ever lit. The largest invisible animal on Earth. Present everywhere in the evidence. Absent from every photograph. That was the wall science kept hitting. Until at last it didn't. The wall broke in 2004. Off the coast of Japan, two researchers had spent years thinking about the problem differently. Instead of chasing the giant squid with lights and engines and hoping to stumble across it, they would set a trap and wait. They lowered a baited line more than 900 meters down into the band of deep water, where sperm whales were known to hunt, reasoning that where the whales fed the squid must be. Then they rigged a camera to fire on its own again and again in the dark. For hours, nothing. Then a giant squid came up out of the black and seized the bait. The camera caught it. More than 500 frames taken over 4 hours as the animal fought the line, its long feeding tentacles lashing out, gripping, straining against the hook. At one point, a tentacle tore free and was left behind, still writhing, still gripping when the squid finally pulled away. These were the first images ever made of a living giant squid in the wild. Not a corpse, not a stranded body going soft on a beach. A living animal hunting, fighting, behaving exactly as a predator behaves. And the images rewrote the story. The old idea had been of a sluggish drifter hanging limp in the deep, waiting for food to bump into it. The photographs showed the opposite, an active, aggressive hunter striking with speed and force. Scientists still debate the finer points of how it hunts. But the drifting monster picture died the day those frames came back up. Centuries of corpses, and then at last, a single living glance. 8 years after the photographs, the giant squid finally moved on film. 2012. A joint expedition of Japanese and international scientists went down into the deep water south of Japan near the Ogasawara Islands in a small submersible built to withstand the pressure. They had learned from the past. Bright lights and loud engines had failed for decades, likely frightening the animal away before any camera could find it. So this time they went quiet. And they went dark, and they carried a different kind of bait. At around 630 meters down, it came. A giant squid rose into the faint glow of the submersible's special lighting, tuned to a color the animal could not easily see. It approached the bait, it gripped, and for the first time in human history, a living giant squid was recorded moving through its own world, its arms fanning its great eye, catching the light, its body holding steady in the black water with a control no corpse had ever hinted at. The footage stunned even the researchers who captured it. The animal was not a limp ghost. It was poised, deliberate, alive in a way that decades of dead specimens could never convey. One scientist aboard described the moment as the culmination of a lifetime of searching. Watch that footage and something shifts. The giant squid stops being a legend, a rumor, a shape assembled from wreckage. It becomes an animal, one that hangs in the dark, watching the strange machine that has come to watch it. Two intelligences meeting across an enormous gulf in a place sunlight has never touched. The monster at last had a face. Now, to the question everyone asks first. How big does it actually get? The honest answer is about 13 meters from the tip of the mantle to the ends of the outstretched feeding tentacles. That is the length most scientists accept for the largest reliably measured specimens, roughly the length of a school bus, front bumper to back. Hold that image because it is the truth, and the truth is astonishing enough. An animal as long as the bus that carried you to school, hanging in the dark ocean hunting. No exaggeration required. But that 13-meter figure hides something important. Most of that length is not body. It has reached the two long feeding tentacles stretched out to their full extent, thin and whip-like, accounting for the majority of the animal's measured span. The substantial part, the muscular core, is far smaller than the headline number suggests. This is where the giant squid gets misunderstood. People hear 13 meters and picture 13 meters of solid monster. The reality is a modest body trailing enormous limbs, more spider than whale in its proportions if a spider could grow to the length of a bus. Females run larger than males, a pattern that holds across the species. And the very largest individuals, the true giants, are almost never the ones science gets to measure. They are estimated, extrapolated, glimpsed. The record holders, if they exist, remain down in the dark where no tape measure reaches. So 13 meters is the working figure, the defensible one. It is not the biggest number ever claimed for this animal. That distinction belongs to a myth we are about to take apart. Strip away the limbs, and what remains is surprisingly small. The mantle, the muscular torpedo-shaped body that holds the organs, measures only around 2 meters in the largest giant squid. That is the true core of the animal, roughly the height of a tall man. Everything beyond it is arm and tentacle unspooling out into the water. Think of the proportions that way, and the whole creature reorganizes in your mind. Picture a body about as long as a doorway is high, and then imagine limbs erupting from it that stretch out 5 or 6 times that length. The giant squid is mostly reach. The engine is compact. The arms are the empire. This matters for how it lives. That 2-meter mantle houses the 3 hearts, the gills, the digestive system, the great funnel that jets water for propulsion. It is dense with muscle and packed with organs. The limbs, by contrast, are instruments long mobile, studded with suckers built to shoot out, seize, and haul prey back toward the center. It also explains why the animal seems to change shape depending on how you catch it. A giant squid with its tentacles retracted looks like a fraction of the beast it becomes when those limbs extend. The same individual can appear modest or monstrous, depending on a single second of movement. From a wide shot at a distance, the animal reads as a pale streak in the dark, most of its length trailing behind the compact body like a comet's tail. Move the camera closer and the proportions snap into focus. Small hull, vast rigging. A body built to stay lean while its arms do the reaching. The monster measured honestly is mostly limb. 18 meters. You will still see that number today. It is wrong. For generations, the giant squid was said to reach lengths of 18 or even 20 meters, figures that would make it far longer than the largest specimen ever properly measured. These numbers appear in old books and tabloid headlines in the confident claims of people who never held a tape to an actual animal. And they refuse to die. The source of the error is almost funny. A dead giant squid is a stretchable thing. Those 2 long feeding tentacles are elastic in a way the rest of the body is not, and when a fresh carcass is hauled onto a deck or when a decomposing one is measured on a beach, those tentacles can be pulled, stretched, and distorted well past their living length. Measure a slack, stretched tentacle on a soft corpse, and you can add meters to the animal that never existed in life. Add to that the simple human hunger for a bigger monster. Every fisherman wants the record. Every account grows in the retelling. The 18-meter squid was built the same way the kraken was built, from real evidence exaggerated by handling and by hope. When scientists began measuring specimens carefully, using consistent methods, and refusing to count stretched tentacles as reliable length, the numbers settled down. The defensible maximum landed near 13 meters, and the 18-meter giant quietly evaporated. Researchers still debate the true upper limit because the largest individuals are the hardest to catch and measure. But the inflated myth has no support. The animal did not need it. 13 meters of living squid hanging in the black is monster enough without a single meter of exaggeration added on top. Long before the word squid entered the story, sailors were reporting sea serpents, great ribbons of movement at the surface, coils and humps breaking the water. A long shape glimpsed for a moment beside a ship, then gone. For centuries, these reports piled up in ships' logs and harbor taverns, and they hardened into their own legend, the sea serpent cousin to the kraken, another monster stitched together from fragments seen in bad light. Some of those sightings scientists now suspect were giant squid. Picture the scene from the deck. A dying or disoriented squid rises toward the surface, something that occasionally happens. Its long feeding tentacles trail across the water, undulating pale and rope-like. Its arms writhe. To a sailor who has never imagined such an animal that is not a squid, that is a serpent, a long living thing moving where no long living thing should be. The reinterpretation is not certain, and researchers are careful about it. Many sea serpent reports were surely other things, rows of dolphins drifting kelp, oarfish, tricks of the eye on a restless sea. No single explanation covers them all. But the giant squid fits a portion of the accounts uncannily well, especially the ones describing a slender snaking form with no clear head. There is a quiet irony in it. For all those centuries of monster hunting, the monster was often right there, misfiled under the wrong legend. People were seeing the real animal and calling it something imaginary. The deep was showing itself at the surface now and then in the only way it could, through a confused, dying messenger. And every time we wrote down the wrong name. To understand the animal, you have to understand the darkness it lives in. Sunlight does not last in the ocean. It fades fast with depth, and by around 1,000 meters down in the zone where giant squid hunt, there is effectively none of it left. No blue, no gray, no glow. The only light in that world is the light living things make themselves, the cold flicker of bioluminescence, sparking and fading in the black. This is not a dim place. It is the largest habitat on Earth, and it is fully permanently dark. Everything about the giant squid is shaped by that fact. Its enormous eyes exist to gather the faintest traces of light in a place with almost none. Its hunting depends on detecting movement and glow rather than color and detail. Its whole sensory world is tuned to a darkness so complete that surface animals cannot really imagine it. Close your eyes in a windowless room at midnight, and you are still not close. There is always some stray photon in a human room. Down there for hours of depth, in every direction there is none. The deep dark is not the exception on this planet. It is the rule. Most of the living space on Earth by volume is exactly this cold black and under pressure. The sunlit world we know is a thin skin across the top. The giant squid is a citizen of that larger, darker realm. It was never hidden from us out of shyness. It was hidden because it lives in the part of the world our eyes were never built. To enter a place where seeing at all is an extraordinary achievement, and the squid does it better than almost anything alive. Then there is the pressure. And the pressure is almost beyond belief. Every 10 meters you descend into the ocean, the weight of the water above adds roughly another atmosphere of pressure, another full sky's worth of squeezing force pressing in from all sides. At 1,000 meters down where the giant squid moves, that force is around 100 times what you feel standing on a beach. Put a number to the feeling, and it stops making sense, so try this instead. The pressure at that depth is enough to collapse an unprotected steel container as if a giant had closed a fist around it. Submarines have crush depths. Go past them and the hull folds. The giant squid lives well within the range that would destroy machines we build specifically to resist the deep. And it does this without armor. No shell, no rigid frame, no reinforced hull. The squid survives, crushing pressure the way all deep-sea animals do by having no air spaces inside to collapse. Its body is mostly water and soft tissue, and water does not compress. The pressure presses equally on every side of a body that has nothing hollow to crush. So the force that would fold a submarine simply passes through the squid as though it were part of the sea itself. From the deck of a research vessel, none of this is visible. The surface is calm. But lower a camera on a cable watch, the depth counter climb, and somewhere past the point where our own bodies would fail. The giant squid is hanging in perfect comfort, soft, enormous, and entirely at home in a place engineered to destroy anything solid we send after it. The deep is not only dark and crushing, it is bitterly cold. In the depths where the giant squid lives, the water hovers just a few degrees above freezing, a steady, brutal chill that never lifts, never warms with the seasons, never sees a ray of sun. Down there, cold is not weather. It is a permanent condition of existence, the same at every hour of every day of the year. Cold slows life down. Chemical reactions run sluggishly in the chill. Metabolisms idle low. Many deep-sea animals move slowly, live long, and burn energy at a crawl matched to the frigid, resource-poor world around them. And for a long time, scientists assumed the giant squid was one of them. A cold, slow drifter, ancient and unhurried, hanging patient in the dark for decades. That assumption turned out to be spectacularly wrong in a way we will come to. For now, hold the setting itself. Water cold enough to kill a swimmer in minutes. Cold that saps heat from anything warm-blooded that dares descend into it, which is exactly why the sperm whales that hunt down there must return to warmer water above. The giant squid, of course, is not warm-blooded. Its body runs at the temperature of the sea around it. It does not fight the cold or flee it. It simply is the cold, its tissues holding the same near-freezing chill as the water they hang in. So, set the full stage. No light, immense pressure, near-freezing water, unchanging and total. This is not a hostile corner of the ocean the giant squid tolerates. It is the animal's entire world and one it rules. Every so often, the deep gives one up, and the animal arrives on our doorstep as a body on a beach. Strandings are how humanity met the giant squid for most of its history. A carcass rolling in with the tide, or drifting into a harbor, or turning up in a fisherman's net, far from where it lived. These beached and floating bodies were the raw material of every early study. Nearly everything known about the animal for centuries came from the dead ones the ocean chose to deliver. They do not arrive in good condition. A giant squid that reaches the surface is already in trouble, sick, dying or dead, carried up from a world it was never meant to leave. By the time it lands on sand, decay is usually well underway. The pale flesh goes soft. The colors fade. The great eyes cloud. Scientists racing to reach a fresh stranding are racing against rot. And yet these ruined bodies were treasures. Every stranded giant squid was a chance to measure an arm, weigh a mantle, examine a beak, count the suckers, study the eye. Museums were built around them. Careers were spent on them. The whole early science of the animal was assembled from creatures that had washed up already broken. There is something almost mournful in it. The only way to study the giant squid for generation after generation was to wait for the sea to hand you a corpse and to hope it was fresh enough to teach you something before it dissolved. The living animal stayed sovereign in its dark realm. What reached the beach was only what the deep had finished with. And still, from those cast-off remains, we learned nearly everything we knew. Here is a strange fact that trips up everyone who studies the animal. A dead giant squid measures larger than a living one. It comes back to those elastic feeding tentacles. In a living healthy squid, the tentacles have muscle tone. They hold their true proportions, contracting and extending under the animal's control. In death, that control is gone. The tissue relaxes, softens, and stretches, and when a carcass is hauled and handled and laid out for measurement, those long tentacles can be pulled well past any length the animal ever reached in life. So the very specimens science could actually get its hands on the corpses were systematically misleading. They exaggerated the animal's size in the exact place where size was easiest to inflate. The dead squid on the deck told a taller tale than the live one in the deep. It is a little absurd when you lay it out. For centuries, we measured the animal only when it was dead, and death made it look bigger than it was, and so the recorded giant squid was on average a stretched version of the real thing. The corpse was an unreliable witness that always testified in favor of the monster. Scientists eventually accounted for this, measuring the firmer, non-stretching parts of the body, treating relaxed tentacle length with suspicion and settling on more honest figures. The mantle length, the arm structure, the beak size, these hold their proportions and can be trusted. The tentacles in a slack corpse cannot. It is a fitting quirk for an animal wrapped in legend from the start. Even in death, even on the examining table, the giant squid could not quite be pinned to an honest number. It kept right to the end a little of its exaggeration. The fascination is older than science. It reaches back to Aristotle. More than 2,000 years ago, the Greek philosopher catalogued the animals of the sea with a care no one had shown before him. Among the creatures he described was something he called the times teuthos, times a great squid, larger than the common kinds the fishermen brought in, set apart in his writing as a thing of unusual size. He was working from what washed up and what was caught, the same fragments everyone else would work from for the next 2 millennia. But he saw enough to know that some squid grew far beyond the ordinary. That single word is a quiet marvel. It means the giant squid, or something very like it, entered the human written record at almost the dawn of natural history. Before telescopes, before the printing press, before anyone dreamed of a machine that could descend into the deep. A thinker in the ancient Mediterranean already knew that the sea held squid of monstrous scale. He could not have known where they lived or how. The deep was as far beyond his reach as the moon. What he had was the same thing his successors would have, for centuries, a body or a piece of one, and a sharp enough mind to record that it was real and that it was large. There is a long, unbroken thread here. From Aristotle noting his great teuthos to whalers counting beaks, to researchers lowering cameras into the black one. Continuous human effort to name and understand this animal. 2,000 years of chasing the same shadow. And for almost all of it, the shadow stayed exactly one step ahead of every eye that hunted it. Eventually, the animal earned a proper scientific name, Architeuthis. It comes from Greek, and it means near enough chief, squid or ruling squid. The times, Archie times, signaling first rank. The times, teuthis times, meaning squid. The naturalist who coined it working in the 19th century chose a word that crowned the animal above all its relatives. Not merely a large squid. The chief of them, the ruler. Say the name aloud and it carries its own authority. Architeuthis. It sounds like what it describes, something ancient, formal, and vast. A fitting label for the creature that had loomed over sailors' imaginations for generations before anyone could classify it. The name did real work. Before it, the giant squid drifted through human knowledge as a rumor, a monster, a beast without a fixed identity, filed under kraken or sea serpent or simple disbelief. A scientific name pins an animal to the map of life. It says this is a real organism related to these other organisms with a place in the order of things. Architeuthis moved the giant squid out of legend and into biology. For a long stretch, scientists argued over how many kinds of Architeuthis there were. Different corpses from different oceans were given different species names, dozens of them at one point, each new stranding seeming to describe a slightly different animal. The genus became a crowded, confused place full of names that might all be pointing at the same creature. That confusion would eventually be resolved by a tool no 19th century naturalist could have imagined in a way that surprised nearly everyone. But that answer belongs later in this story. For now, the animal had its crown and its name, the ruling squid. One correction has to be made here because the two are constantly confused. The giant squid is not the colossal squid. They are different animals. The giant squid is Architeuthis, long, slender, built around those two whip-like feeding tentacles found across much of the world's deep ocean. The colossal squid is a separate creature entirely Mesonicoteuthis, and it lives in the frigid waters around Antarctica, far to the south. The names invite the mix-up, and so does the size. But their bodies tell them apart. The giant squid is longer overall, thanks to its extraordinary reach, more length, less bulk. The colossal squid is shorter, but far heavier, a thicker, more massive animal, the true heavyweight of the squid world. If the giant squid is a whip, the colossal squid is a club. Their weapons differ too. The giant squid grips with toothed rings of hard tissue lining its suckers. The colossal squid goes further. Its arms and tentacles are armed with swiveling, sharpened hooks, rotating claws that dig into prey. Pound for pound, the southern animal is the more fearsome instrument. Picture them side by side, though they never meet in life. The giant squid, elongated and pale, all reach and grace. The colossal squid, squat and heavy and hooked, built for a brute grip in the coldest water on Earth. Two monsters, two blueprints. One ocean between them and worlds apart in design. So when the giant squid is called the largest of its kind, that needs a careful footnote. Longest, yes. Heaviest, no. The crown in the end is shared, and the two rulers have never once laid eyes on each other. Where exactly does the giant squid hunt? The answer is a band of water we are only beginning to map. The evidence points to the deep middle ocean, roughly the zone between 300 and 1,000 meters down, and likely deeper still. Not the very bottom where the seafloor lies, but the vast open water column above it, the twilight and the darkness below the twilight, the largest and least explored living space on the planet. We know this partly from the whales. Sperm whales dive into exactly these depths to hunt, and their stomachs full of beaks mark the giant squid's territory as surely as tracks in snow. Where the great toothed whale goes to feed the squid is waiting. The predator maps the prey. We know it too, from the depths at which the living animals were finally filmed, hundreds of meters down, well below sunlight, deep in the open dark. And from the depths where dying specimens are occasionally netted or seen rising toward the surface, spent and disoriented. But the edges of that range stay fuzzy. How deep does it truly go? No one is certain. The lower boundary of its world has never been fixed because the deeper you search, the harder the searching becomes, and the animal has a long history of eluding every method used to find it. Suspend a camera in that middle water, in the black between the sunlit top and the distant floor, and you are hanging in the giant squid's living room, an immensity of open, lightless ocean stretching in every direction. Somewhere in it, more than we can count, the animals hang and hunt. We know the neighborhood. We have barely begun to learn the address, which leads to the largest gap of all. No one knows how many there are. Not even roughly. There is no census of the giant squid, no reliable population estimate, no confident figure a scientist can offer when asked how many are down there. The animal that has fascinated humanity for 2,000 years remains in this basic way entirely uncounted. The clues that exist point in a strange direction toward abundance. Those sperm whale stomachs packed with beaks imply that giant squid are eaten in enormous numbers, which means they must exist in enormous numbers to sustain the loss. A predator does not build its diet around a rare animal. The math of the whale's appetite suggests a deep ocean quietly teeming with squid. And yet almost no one ever sees a living one. The two truths sit oddly together, likely common yet nearly invisible. It is the invisibility paradox pushed to its limit. An animal abundant enough to feed the largest predators on Earth, and elusive enough that filming a single individual alive was a landmark event of the 21st century. Researchers still debate the numbers because they have almost nothing solid to debate with. Estimates where they exist are built on indirect evidence, whale diets, stranding rates, guesses layered on guesses. The honest position is that the population size is simply unknown. So stage one closes on the shape of the mystery itself. An enormous animal known first from corpses wrapped in the kraken's legend, hidden by darkness and pressure and cold, finally glimpsed alive after centuries of searching and still uncounted its true numbers, a blank on the map. We know the monster is real. We do not yet know how many monsters there are. Now the body. And nothing about the body announces itself like the eyes. The giant squid has the largest eyes of any animal known to science, living or extinct, each one roughly the size of a dinner plate, close to a foot across. Picture a plate you would set a full meal on, then set it into the side of a living head. That is the scale of a single giant squid eye. Nothing else on Earth comes close. The eye of a large fish is a marble beside it. The eye of a horse, of a whale, of an elephant, all dwarfed. Only the colossal squid to the south rivals it. Among all the animals that have ever opened an eye on this planet, these two deep-sea giants hold the record, and it is not a close contest. Set that eye against something familiar, and the strangeness sharpens. A giant squid's eye is larger than a human head. If you stood face to face with the animal in the deep, a single one of its eyes would be wider than your whole skull, staring back at you, gathering what little light there was to gather. The eye is not merely large for show. Its size is a solution to a problem, the problem of seeing at all in a place with almost no light. Every added millimeter of diameter lets the eye collect more of the faint glow that filters and flickers through the deep. In near total darkness, a bigger eye is a better eye, and the giant squid took that logic further than any other creature alive. Up close, in a submersible's beam, that vast dark orb dominates the animal's face. An eye built not to be looked at, but to look in a world where looking is nearly impossible. Why so big though? Even for the dark deep, the giant squid's eye seems to overshoot, and that puzzle led to a striking answer. Most deep-sea animals get by with large eyes, but not eyes this large. Past a certain size, the returns diminish, an eye keeps growing heavier and more costly, while its ability to gather dim light improves only slightly. So, a plate-sized eye is in a sense overbuilt for simply spotting food or finding a mate in the black. Something else must be driving it. A team of scientists modeling the physics of deep-sea vision proposed a compelling idea. The giant squid's eye, they argued, is not sized to see small prey up close. It is sized to detect one specific threat at a great distance, the sperm whale. Here is the logic. A hunting sperm whale plunging through the deep disturbs the water and triggers the bioluminescent plankton around it, lighting up a faint spreading halo of cold light as it moves. A large enough eye could catch that glow from far off, spotting the approaching whale while there was still time to flee. At the enormous size of the giant squid's eye, and only at that size, the researchers calculated the animal could detect a moving whale from many meters away in the dark. The eye in this view is an early warning system aimed at the one predator big enough to eat it. Scientists still debate whether this is the full explanation. It is a hypothesis, elegant but not proven, and other pressures surely shape the eye as well. Yet it reframes the whole animal. That dinner plate eye may be less about hunting than about being hunted, a watchtower against the whale built by fear into flesh. Follow that idea into the water, and the deep starts to glow. The deep ocean is not perfectly uniformly black. It is threaded with bioluminescence, countless tiny organisms that flash and shimmer when disturbed, sparking cold light into the dark. A body moving through that water leaves a wake of light behind it, a trail of triggered glimmers marking its passage the way a boat leaves a wake of foam. For the giant squid watching with those enormous eyes, this changes everything. It does not need to see the sperm whale directly. It needs only to see the light the whale kicks up, the spreading disturbance of glowing plankton around a body plunging down from above. A vast shape approaching in silence, wrapped in a faint halo of provoked light. That halo is the warning. The eye is tuned for exactly this, large enough to catch a dim, distant glow, sensitive enough to register a change in a nearly lightless field. The giant squid in this picture spends its life watching the dark for the particular shimmer that means a whale is coming, and catching it jets away into deeper black before the hunter arrives. From the whale's side from above, the descent is a hunt in the dark, all echolocation and appetite. From the squid's side from below, it is a vigil, an eye the size of a plate fixed upward, reading the faint light of the water for the one signature that means death. Two of the ocean's giants locked in a contest older than any human memory, one diving down to hunt by sound, one hanging below watching by light. The whole drama plays out in a darkness where to any human eye there would be nothing at all to see. Turn from the eyes to the limbs, and count them carefully because the arrangement is not what most people assume. The giant squid has 10 limbs, but they are not 10 of a kind. 8 of them are arms, thick, muscular, lined with suckers along their length fanning out from around the beak. The other 2 are something different. They are the feeding tentacles, much longer, largely smooth along their stalks, with the grasping equipment concentrated at their far ends. This 8+2 design is the signature of the squid, and the giant squid follows it on a monstrous scale. The 8 arms handle the close work, holding, manipulating, guiding food toward the mouth once it has been caught. They are the hands. The 2 long tentacles are the reach, the tools that shoot out to seize prey at a distance and drag it back within range of the arms. Get the count right, and the animal makes more sense. It is not a mess of identical writhing limbs as the old woodcuts of the kraken suggest. It is an organized instrument with a clear division of labor, 2 arms for striking far, 8 for working close. The proportions are extreme. Those 2 feeding tentacles are what make the animal so long overall, stretching out several times the length of the 8 arms when fully extended. Retracted, they shorten and thicken. Extended, they transform the squid into the elongated giant of legend. From a distance in open water, an untrained eye reads all 10 as a single tangle. Move closer, and the structure resolves, the 8 arms clustered like a crown around the head, and the 2 long tentacles trailing beyond them, waiting coiled, ready to fire out into the dark and take hold of whatever passes. Those 2 feeding tentacles do not merely reach, they strike. When prey drifts within range, the giant squid does not swim it down and grapple it. It fires, shooting the long feeding tentacles outward in a sudden lunge, extending them far beyond the reach of the arms to seize the target before it can react. The strike is fast, and it happens in the dark, and for most of history no one had witnessed it. Then the deep-sea cameras finally caught it in the act. Think of the mechanism as something coiled and released, less like an arm swinging and more like something launched, a fast extension out into the water, the grasping club at the tip snapping onto the prey. The 8 arms wait. The 2 tentacles do the seizing. It is an ambush built into the animal's anatomy. The 2004 photographs off Japan captured this directly. When the giant squid struck the baited line, its feeding tentacles lashed out and gripped with such force that one tore free rather than release the severed limb, still clutching the bait as the animal pulled away. That was the moment the old picture of a sluggish drifter finally died. This was a predator that hit its target hard. Scientists are still working out the finer mechanics, exactly how fast the strike is, how the tentacles coordinate, how the animal judges the distance in the dark. The footage is precious and rare, and each clip adds a little more. But the essential truth is settled now. The giant squid is not a passive filter of the deep waiting for food to blunder into it. It is an active hunter that reaches out across the black water and takes what it wants, striking first and holding on with everything it has. Once the tentacles land, the prey is not merely held, it is gripped by hundreds of specialized locks. Along the inner surface of the arms and the clubbed tentacle tips run rows of suckers, but a giant squid sucker is not a simple suction cup. Each one is ringed with a circle of hard-toothed tissue, a serrated collar of chitin lining the rim. When the sucker clamps down, that ring of little teeth bites into the surface, it grips, digging in, so the hold cannot easily slip. It is suction and teeth working together. The soft cup seals and pulls, the toothed ring anchors and scores. A prey animal caught in that grip is not just stuck to the squid, it is hooked into it, held by dozens or hundreds of these clawed suckers at once, each one biting down independently. This is why the giant squid leaves marks. When a sperm whale carries the scars of a battle with one, those scars are rings, circular scratches gouged into the whale's skin by the toothed sucker collars, a permanent record etched by the struggle. The evidence of the fight is written directly onto the survivor. Picture the club at the end of a feeding tentacle, closing on a fish. In a fraction of a second, that whole grasping surface engages the suckers, sealing the rings, biting the grip, tightening past any hope of escape. Then, the arms move in to take over, and the prey is passed hand to hand toward the center. The toothed sucker ring is a small thing, no wider than a coin at its largest. But multiplied across the limbs, closing all at once, it turns the giant squid's embrace into something almost impossible to break, a grip built to hold prey that very much does not want to be held. The real weapon sits at the very ends of the two feeding tentacles. Biologists call it the club. Each long feeding tentacle is mostly a smooth, muscular stalk, but at its tip, the limb widens and transforms into a broad, flattened grasping structure crowded with suckers. This is the club, and it is the business end of the strike. The stalk delivers the reach, the club delivers the grab. When the tentacle fires out into the dark, it is the club that slams onto the prey and takes hold. The design is precise. The suckers on the club are arranged in dense rows, often larger and more powerful than those along the arms, concentrated exactly where the catching happens. Some are positioned to help the two clubs lock onto each other as well, so that when both tentacles strike a single target, their tips can zip together and pin the prey between them in a double grip. Everything about the club is built for the instant of capture. Before the strike, it hangs at the end of the trailing tentacle, quiet waiting. In the strike, it becomes the point of contact, the first part of the animal to touch its meal and the part that decides whether the meal escapes. Zoom the camera in on that club tip and you are looking at the giant squid's cutting edge, a mass of gripping suckers at the far end of an enormous reach held in reserve until the moment prey drifts close enough to take. It is a strange and specialized piece of anatomy. Most of the tentacle is simply a delivery system, meters of muscle whose only job is to put the club where it needs to be. The club is the reason the whole long limb exists. Now stretch those limbs out to their full extent, and the reach becomes almost hard to believe. When a giant squid fully extends its two feeding tentacles, they unspool to length several times that of its body, the animal's grasp stretching out many meters into the surrounding water. A squid, whose muscular core is only about 2 meters long, can reach out and seize prey a striking distance away, its clubs arriving at targets its body never has to approach. This is the giant squid's great advantage in the dark. It does not need to close with its prey. It hangs mostly still and lets the tentacles do the traveling, flinging its grip outward across a volume of water far larger than its body occupies. The reach turns a modest-bodied animal into a predator, commanding a huge sphere of hunting space around itself. Set the scale against something you can pace out. Imagine standing at one end of a modest swimming pool and being able to reach across nearly its full length to grab something at the far side without moving your feet. That is roughly the disproportion between the giant squid's compact body and the distance its tentacles can cover. The reach also explains the animal's long trailing silhouette. Those extended tentacles are what people saw at the surface and called sea serpents. They are what stretched on the deck and inflated the 18-meter myth. The very feature that makes the squid such an effective ambush hunter is the feature that made it so easy to misunderstand. Coiled and ready, the tentacles wait. Then they fire, and for that instant, the giant squid's grasp extends across a stretch of black water wider than almost any other predator can command from a standstill. Move inside the body now, past the limbs, and the strangeness deepens. The giant squid runs on 3 hearts. Not 1. 3. 2 of them are branchial hearts, each dedicated to a single gill. Their job is to push blood through the gills, where it picks up oxygen from the water. The third is the systemic heart, the central pump, which drives that freshly oxygenated blood out to the rest of the body. A 2-heart booster stage feeding one main engine. This is the standard cephalopod plan shared with octopuses and other squid, and it is a genuinely different way to build a circulatory system than the one running inside you. Your single heart does all the work. The giant squid divides the labor-dedicated pumps for the gills, a separate pump for the body. 3 organs beating in coordination to keep blood moving through an enormous animal in cold oxygen-poor water. There is a logic to it. Pushing blood through the fine vessels of the gills takes real force, and handing that task to 2 specialized hearts frees the main one to focus on circulation everywhere else. In the frigid deep, where oxygen is scarce and the body is large, that division of labor helps the system keep up. 3 hearts beating inside a body, as long as a doorway is tall, in near-freezing black water, moving blue blood through a 2-meter mantle. Nothing about it maps onto our own anatomy. The giant squid is not a bigger version of a familiar animal. It is built on a wholly different blueprint, and the triple heart is only the first sign of just how far that blueprint departs from ours. And the blood those hearts pump is not red, it is blue. The giant squid, like all cephalopods, carries oxygen through its body using a molecule called hemocyanin, and where our blood is built on iron, theirs is built on copper. Iron binds oxygen and turns red. Copper binds oxygen and turns blue. So, the blood moving through those 3 hearts runs a pale blue, coloring the animal's insides in a shade no vertebrate ever wears. It is not a small cosmetic difference. It reflects an entirely separate evolutionary solution to the same universal problem: how to grab oxygen in one place and carry it to another. Vertebrates like us solved it with iron-based hemoglobin packed into red blood cells. Cephalopods solved it with copper-based hemocyanin dissolved directly in the blood fluid itself, no cells required. 2 lineages. 2 metals, 2 colors. Picture the animal open to the light of a submersible or a laboratory. Blue blood, 3 hearts, a body with no bones. Every internal detail insisting that this creature comes from a branch of life that split from ours in the deep past and never looked back. The blue blood is more than a curiosity too. As the next fact will show, copper-based hemocyanin has a particular advantage in exactly the kind of world the giant squid inhabits, the cold and the low oxygen of the deep. For now, hold the image. When a giant squid is wounded in the dark, it does not bleed red. It leaks a faint cold blue into the black water, the color of copper meeting oxygen, the signature of a lineage that built its life on a different metal than our own. That copper-based blood is not a quirk. In the cold, oxygen-starved deep, it is an advantage. Hemocyanin, the blue-copper molecule, has a useful property. It carries oxygen especially well in cold water, and at low oxygen levels, precisely the conditions the giant squid lives in. Down in the near-freezing dark, where oxygen is thin and the pressure is immense, copper-based blood outperforms the iron-based kind for grabbing what little oxygen is available and holding onto it. There is a trade-off, of course. In warm, oxygen-rich water hemoglobin, our iron system is generally the more efficient carrier. But the giant squid does not live in warm, rich water. It lives in the cold and the scarcity, and there hemocyanin comes into its own. The animal's blood is matched to its world. This is a recurring theme in the giant squid's body. Again and again, features that look strange from a surface perspective turn out to be precise solutions to the demands of the deep. The huge eyes for the darkness, the soft waterlogged body for the pressure. And now the blue blood for the cold and the low oxygen. Nothing is arbitrary. Every oddity is an answer. It reframes how to see the animal. The giant squid is not a monster that happens to live in a hostile place. It is a creature so thoroughly shaped by that place that its very blood chemistry is tuned to it, a body that could only have been built in the deep for the deep. Take the animal out of the cold and the low oxygen up into warm surface water, and that same finely tuned system begins to fail. The blood that serves it perfectly below cannot cope above, which is one more reason the giant squid hauled toward the surface so rarely survives the journey. At the center of all those arms where the limbs converge sits the animal's one hard weapon, a beak. It looks startlingly like a parrot's beak, 2 curved, interlocking jaws of hard black chitin, sharp-edged and powerful, set at the exact point where the 8 arms meet. In a body that is almost entirely soft, this is the one rigid cutting tool, a mouth built to bite through flesh positioned at the hub of everything the limbs bring in. The design is brutally effective. The upper and lower halves of the beak scissor past each other, slicing rather than crushing, capable of shearing chunks from prey far larger than the mouth itself. Everything the tentacles seize and the arms deliver ends up here at the beak, to be cut down into pieces small enough to swallow. This is the part that survives when everything else is gone. In a sperm whale's stomach, the soft body of a swallowed squid dissolves, but the chitinous beak endures, which is exactly why whalers found them by the thousands, and why beaks became the first hard proof that the deep was full of these animals. The one indigestible piece of the squid is also its one hard weapon. Hold a giant squid's beak and it surprises you. Dense, sharp, heavier than its size, suggests clearly built to cut. It is the single part of the animal that would not look out of place on a bird of prey, transplanted improbably into the middle of a mass of boneless arms. And it is where the hunt ends. The tentacles strike, the arms grip the prey, is hauled inward, and it all arrives finally at this small black beak, waiting at the center, the point where a caught animal stops being prey and starts being a meal. The beak cuts, but behind it waits an even stranger tool for the eating, a tongue covered in teeth. Inside the mouth past the beak sits the radula, a ribbon-like structure lined with rows of tiny, hard, backward-facing teeth. It works like a rasp or a file. As food is cut by the beak and passed inward, the radula scrapes and drags it back into the gullet, its rows of teeth gripping and pulling the pieces down into the animal. It is a piece of anatomy with no counterpart in our own mouths. Imagine a tongue whose surface is not soft and smooth, but paved with rows of minute teeth all angled to move food in one direction inward toward the throat. That is the radula, a conveyor built of teeth hauling each cut piece deeper with every pass. The radula is a signature of the mollusks, the great group to which squid, octopuses, snails, and slugs all belong. A garden snail has one, so does the giant squid. But in the giant squid, it is scaled up and set behind that formidable beak part of a two-stage processing line for turning prey into swallowed food. Together, the beak and the radula form an assembly. The beak shears the prey into manageable pieces. The radula drags those pieces inward and down. Cutting tool, then conveyor. One slices, the other feeds. Between them, they break a caught fish or squid down and move it steadily into the gut. Zoom in on that mouth and you are looking at something genuinely alien, a hard black scissor beak, and behind it a rasping ribbon of teeth, working in sequence at the center of an animal that has no bones anywhere else in its enormous body. Now, how does something with no fins to speak of move a body this large through the deep? It uses a jet. The giant squid, like other squid, propels itself by jet propulsion. It draws water into the large cavity of its mantle, then squeezes that muscular body and forces the water out through a narrow, flexible tube called the funnel. The water shoots out one way, the animal is driven the other. Fill, squeeze, expel, and the squid rockets backward through the water, powered by nothing but the sea it just took in. It is a genuinely elegant system, and the same principle a rocket uses: push mass in one direction to move in the other. The mantle is the chamber, the funnel is the nozzle, and the animal's own muscle is the engine. No propeller, no tail, no beating fins required, just the rhythmic pumping of water through the body. The funnel does more than provide thrust. It can swivel and aim, letting the squid direct its jet, and therefore steer, pointing the nozzle one way to shoot the other. Combined with the animal's fins for fine control, the jet gives the giant squid surprisingly precise command over where it goes in three-dimensional space. For quick escapes, the jet is the key. A giant squid that senses a sperm whale's approaching glow does not slowly paddle away. It fills its mantle and fires a hard jet of water through the funnel, launching itself into deeper darkness in a sudden burst of speed, the same propulsion system driven to its limit. Watch it from the side, and the motion is unmistakable. The body pulses the mantle, contracts water, blasts from the funnel, and the great animal surges through the black, moving not by swimming as a fish swims, but by breathing the ocean in and blasting it back out. Here is one of the giant squid's most peculiar tricks, and it explains why the animal can hang motionless in the deep without sinking. Its flesh is soaked in ammonium. Throughout the giant squid's tissues sits a high concentration of ammonium ions, a chemical arrangement that makes the animal's flesh less dense than the surrounding seawater. In effect, the squid loads its body with a substance lighter than the sea, achieving buoyancy from the inside out. It does not need to swim constantly to keep from sinking. Its own waterlogged, ammonium-rich flesh holds it up. This solves a real problem. Many fish use a gas-filled swim bladder to stay afloat at depth, but a gas bladder is a liability under the crushing pressure of the deep, where any airspace is a weakness waiting to collapse. The giant squid takes a different route entirely. Instead of a pocket of gas, it distributes lightness throughout its whole body chemically, saturating its tissues with buoyant ammonium. No airspace to crush, no bladder to fail. The result is an animal that can float effortlessly in the deep, neutrally buoyant hanging, suspended in the black water with little effort. It can hold its ambush position, tentacles ready, eyes watching without swimming to stay in place. For a predator that hunts by waiting and striking, that effortless hovering is a real advantage. There is a cost to this chemistry, though, and it shapes the giant squid's entire relationship with humanity. That ammonium-soaked flesh does not taste the way seafood is supposed to taste. It carries the sharp, acrid flavor of ammonia. The reason, as the story will show shortly, that no one is putting giant squid on a dinner plate. The trick that lets it float is the same trick that keeps it off ours. Follow that chemistry to its conclusion, and you find an animal that floats without any of the equipment other floaters rely on. No swim bladder, no gas at all. Bony fish, for the most part, solve buoyancy with a swim bladder, an internal sac they inflate and deflate to rise and sink. It works beautifully near the surface. In the deep, it becomes a hazard. Gas compresses under pressure, so a bladder that keeps a fish level at one depth betrays it at another, and at the pressures where the giant squid lives. Maintaining a gas-filled organ at all is a losing proposition. The deep punishes air. The giant squid sidesteps the whole problem. By loading its tissues with buoyant ammonium rather than trapping gas in a sac, it achieves neutral buoyancy with no compressible space anywhere in its body. Whether it hangs at 600 meters or 1,000, the physics stays the same because there is no gas to squeeze. Its lightness is built into its flesh, not into a fragile pocket of air. This is why the giant squid can move freely up and down through a wide range of depths without the trouble a swim bladder fish would face. It carries its buoyancy with it, distributed and pressure-proof, immune to the crushing forces that would collapse any airspace. It comes at a price, and the price is muscle. Ammonium-soaked, waterlogged tissue is not dense, powerful, athletic flesh. It is soft, gelatinous, and comparatively weak flesh optimized for floating, not for sustained power. The giant squid trades brawn for buoyancy. The animal that results is a strange one, enormous yet soft, powerful in a strike yet unable to sustain a hard chase for long. A body engineered to hang weightless in the deep and in the hanging, to give up the dense muscle a surface predator would take for granted. That same buoyancy chemistry answers a question people often ask. Why don't we eat giant squid? The answer is the taste. It tastes of ammonia. The very ammonium that keeps the animal afloat saturates its flesh, and ammonium carries a sharp, bitter, acrid flavor, the harsh chemical bite of ammonia closer to a cleaning product than to food. A giant squid steak would not taste like the tender calamari pulled from smaller species. It would taste bluntly foul. This sets the giant squid apart from nearly all its relatives on the menu. Ordinary squid are a staple of seafood cuisine the world over, prized for their mild flavor and firm texture. But those edible squid do not use ammonium buoyancy the way the giant squid does. The giant squid's particular survival strategy is precisely what ruins it as food. There is a certain grim comedy in it. Humanity spent centuries hunting this animal in imagination, building it into the ship-devouring kraken, the monster of the deep. And when we finally understood the real creature, one of its defining features turned out to be that it is essentially inedible. The great sea monster is on the plate a disappointment. The taste also spares the giant squid, a pressure that has devastated so many other large ocean animals. It is not commercially fished for food. There is no fleet chasing it for its meat, no market driving its capture, because no one wants to eat something that tastes of ammonia. Its inedibility is a kind of accidental protection. So the chemistry closes a neat loop. The ammonium lets the animal float. The floating lets it live as it does in the deep. And the same ammonium tasted on the tongue keeps humanity from ever developing an appetite for the monster it spent so long fearing. Return to the business of staying alive down there, and one need overrides all others. Oxygen. In cold, deep water, the giant squid must pull it from a stingy sea. The animal breathes through gills, two large feathery structures inside the mantle cavity, richly supplied with blood by those two dedicated branchial hearts. As water passes over the gills, oxygen crosses from the water into the blood, where the copper-based hemocyanin binds it and carries it away to the body. It is the same basic task every gilled animal performs, but done under difficult conditions. The deep water the giant squid inhabits can be low in oxygen. Some depths of the ocean hold far less dissolved oxygen than the surface-forming zones where breathing is genuinely hard. The giant squid's whole respiratory setup is tuned to extract oxygen efficiently, even when there is little to be had. Large gills, dedicated pumping hearts, and blood chemistry optimized for exactly these cold, oxygen-poor conditions. Every piece works together. The branchial hearts drive blood hard through the gills. The gills present a large surface to the passing water. The hemocyanin grabs oxygen well in the cold. Together they let a very large animal keep its tissues supplied in water that would leave a less specialized creature gasping. It also ties back to the animal's soft, low-powered muscle. A giant squid built for explosive, sustained athletic effort would demand far more oxygen than the deep can readily provide. Its gelatinous ammonium-laced body, capable of a fast strike but not a long chase, is partly a concession to that scarcity. You cannot run a high-performance engine on a thin supply of fuel, so the giant squid breathes carefully, extracting what it can from a reluctant sea, its whole physiology arranged around the quiet difficulty of finding enough oxygen in the cold and the dark. The mantle is more than a container for organs. It is a pump, and the whole system of breathing and moving runs through it. That muscular torpedo-shaped body wall does double duty. It houses the animal's insides, and it drives the flow of water that keeps the squid both breathing and moving. The rhythm is continuous. The mantle relaxes and draws water into the cavity around the gills, then contracts and pushes that water back out through the funnel. Every cycle serves two purposes at once: passing fresh, oxygen-bearing water over the gills, and when needed, providing the jet that propels the animal. It is an efficient marriage of functions. In gentle, ordinary breathing, the mantle pumps water over the gills at an easy pace, keeping oxygen flowing without much effort. When the squid needs to move, the very same muscular contraction is simply driven harder, forcing a stronger jet through the funnel and launching the animal through the water. Breathing and swimming are not separate systems. They are the same pump run at different intensities. This is why a startled giant squid can go from stillness to sudden flight in an instant. The machinery for escape is the machinery it uses every moment just to breathe, always primed, always ready to be pushed harder. There is no engine to start up. The engine is already running. Watch the animal hang in the deep and you can see the quiet rhythm of it if the light catches right, the slow, steady pulse of the mantle drawing water in and pushing it out, the patient breathing of an ambush predator at rest. Then, at a threat, that same pulse becomes a hard contraction, water blasts from the funnel, and the giant squid is gone into the dark. One muscular body wall. Two jobs. The steady work of staying alive and the sudden work of staying alive. Step back and take in the whole strange inventory, because the giant squid is not built on our plan at all. Its nervous system follows an entirely different design. Consider what has already been counted. 3 hearts, not 1. Blue blood, not red. 10 limbs, not 4. A beak and a toothed radula instead of jaws and a tongue. Buoyant, ammonium-soaked flesh instead of a swim bladder. Jet propulsion instead of fins first swimming. Every major system built to a blueprint that diverged from ours in the deep evolutionary past, when the ancestors of mollusks and the ancestors of vertebrates went their separate ways. And the nervous system may be the strangest departure of all. The giant squid's brain is not a single mass tucked safely in a skull. It is arranged around the animal's throat, a ring of nervous tissue encircling the gullet, so that food literally passes through the center of the brain on its way to the stomach. Nothing in vertebrate anatomy is remotely like it. This is worth dwelling on before the next stage because it sets up everything about how the animal behaves. A body this alien is not a monster in the horror sense. It is monstrous in the older sense of the word, a marvel, a thing that provokes wonder, a form of life so far from our own that it forces us to expand what we think an animal can be. The giant squid is a working demonstration that evolution had more than one answer to almost every problem. Circulation, respiration, buoyancy, propulsion, sensing, thinking, for each it found a solution, unlike the vertebrate one, and made it work at enormous scale in the hardest environment on Earth. Hold that whole alien inventory in mind. Because now, the animal starts to move, and the way it hunts, sees, and thinks is stranger still. Now the hunt in motion. And it begins with a strike faster than the eye can follow. The giant squid hanging still in the black detects prey, a fish, another squid drifting within range. There is no chase, no slow approach. The 2 feeding tentacles fire. In a single fast extension, they shoot out across the water, the club tips arriving at the prey before it has time to flee, and the suckers slam home. From stillness to capture in a heartbeat. This is ambush hunting, refined to a point. The animal spends the effort not on pursuit but on patience, hovering, watching, waiting for something to drift close enough. All the speed is compressed into that one explosive moment when the tentacles launch. Energy conserved, then spent all at once. The strike is quick enough that in the rare footage that exists, it is nearly a blur. One frame shows the tentacles coiled and ready. The next shows them extended and gripping. Whatever happened in between happened faster than a casual glance could track. In the dark against unsuspecting prey, that speed is lethal. It also fits everything already established about the body. The soft, buoyant flesh cannot sustain a long, powerful chase, so the giant squid does not attempt one. It stakes its whole hunting strategy on a single fast reach. Float in place at no cost, watch with those enormous eyes, and when the moment comes, strike once hard and rarely miss. Up close, the strike would be almost impossible to witness in real time. A sudden lash of pale limbs out of the dark, a grip that closes in a fraction of a second, and a fish that was swimming freely one instant and caught the next. The giant squid does not run its prey down. It waits. and then it takes it quicker than sight. The strike lands. Now comes the grip, and the grip is the point of no return. The instant the clubbed tentacle tips make contact, hundreds of toothed suckers engage at once, sealing and biting into the prey. Then the two tentacles haul the catch inward, drawing it back toward the waiting crown of 8 arms, and those arms close around it too, adding their own rows of clawed suckers to the hold. What began as a strike becomes an embrace of overwhelming force. There is very little a caught animal can do against it. Each individual sucker is small, but there are hundreds of them, each one sealed and toothed and gripping independently distributed across limbs far stronger than the prey. To break free, a captured fish would have to defeat every one of those grips at once, against the pull of an animal many times its size. It almost never happens. This is where the toothed sucker rings prove their worth. Simple suction might slip on a struggling slime-coated fish. Suction backed by a ring of biting teeth does not. The prey is not merely stuck to the squid. It is hooked into it at hundreds of points, held by a grip designed specifically to defeat the thrashing of something that does not want to die. The whole apparatus funnels the catch in one direction, inward toward the center, toward the beak. The tentacles reach and seize. The arms receive and hold. The grip tightens and draws everything toward the mouth at the hub. It is a one-way journey. Once the suckers lock and the arms fold in, the prey's path leads only to the beak. From the moment of contact, the outcome is essentially settled. The giant squid's grip is not a hold the prey might escape. It is the closing of a trap. Everything the limbs catch travels the same road, inward to the beak, hand over hand. Once the prey is gripped, the 8 arms go to work as manipulators, passing the catch from sucker to sucker, arm to arm, drawing it steadily toward the center where the limbs converge. This is the arm's primary role in the hunt, not the initial strike which belongs to the tentacles, but the close handling that guides the meal into position. They are the hands that bring the food to the mouth. The movement is deliberate and controlled. The prey, held fast by hundreds of suckers, is worked inward along the arms toward the beak waiting at the hub. There is no rush now. The catch is secured, escape is impossible, and the animal simply feeds its meal into the cutting jaws at its own pace. The violence of the strike gives way to the mechanical patience of processing. Picture the geometry of it. The 8 arms fan out from around the beak like the spokes of a wheel from its center. Prey caught at the far end of that reach is walked steadily down the spokes toward the hub, drawn along by wave after wave of gripping suckers, until it arrives at the one hard point in the whole soft animal, the black beak waiting at the middle. This is why the giant squid's body is arranged as it is, with the mouth set at the exact convergence of the limbs. Every arm is a road, and every road leads to the beak. Whatever the tentacles seize, the arms deliver to the same destination. By the time the prey reaches that center, the hunt proper is over. What remains is no longer capture but consumption, the steady, unhurried work of a predator that has already won, feeding its catch into the jaws at the heart of its ring of arms. At the center, the meal meets the processing line. Beak then, radula cut, then convey. The prey arrives at the beak, whole, or nearly so. The beak goes to work first, its hard chitin jaws scissoring past each other to shear the catch into pieces small enough to swallow. A large fish is not gulped down entire. It is cut apart at the mouth, sliced into manageable portions by those sharp interlocking jaws. The beak is the butcher. Behind the beak, the radula takes over. That ribbon of backward-facing teeth grips each cut piece and drags it inward, hauling the food back off the beak and down into the gullet. Where the beak slices, the radula pulls. One tool severs the prey, the other conveys it into the body. Together, they form a 2-stage line for turning a caught animal into swallowed food. It is an efficient division of labor, and a necessary one. The beak alone could cut but not swallow. The radula alone could pull but not sever. Working in sequence, they handle prey of considerable size, the beak reducing it to pieces, the radula feeding those pieces steadily inward, the whole process advancing without pause until the meal is gone. This assembly sits at the heart of the animal, at the convergence of the arms encircled as established by the ring-shaped brain. So the food passes not only through the beak and past the radula, but through the very center of the nervous system on its way to the gut. Cutting, conveying, and thinking all stacked at the same central point. The hunt that began with an explosive strike out in the dark ends here quietly at a small black beak and a rasping ribbon of teeth, the giant squid's processing line methodically dismantling the catch, its long reach brought in. Which raises a genuinely strange consequence of the giant squid's anatomy. Its food is broken down before it ever reaches the stomach, and it passes through the brain to get there. Recall the arrangement. The brain is a ring of nervous tissue wrapped around the esophagus, the tube that carries food from the mouth toward the gut. So in the giant squid and in cephalopods, generally every swallowed piece of prey travels directly through the hole in the center of the brain. The gullet threads the donut. The meal passes through the mind. This puts a hard limit on the design. Because the esophagus runs through the middle of the brain, the food moving down, it cannot be too large or too sharp a chunk. Big enough to stretch the gullet excessively would press on the surrounding brain tissue. This is widely thought to be exactly why the beak and radula matter so much. The prey must be cut and rasped into small, safe pieces before it can be sent down through that delicate central ring. It is a genuinely bizarre engineering constraint. In our own bodies, brain and gut are kept well apart, and we can swallow surprisingly large mouthfuls without any risk to our thinking. The giant squid enjoys no such separation. Its throat runs through its brain, and so it must reduce every meal to fragments before swallowing process first, then eat. Consider what that means for the hunt as a whole. The explosive tentacle strike, the overwhelming grip, the inward haul, the beak, the radula, the entire elaborate sequence exists in part to solve one deep-seated problem: how to get a large prey animal safely past a brain wrapped around the throat. An animal built so differently from us that even the simple act of swallowing had to be engineered around the strange place it keeps its mind. In a world without light, one sense rules the giant squid above all others: sight. It seems almost contradictory. The deep is dark, effectively lightless in the depths where the animal hunts, and yet the giant squid has invested more in vision than in anything else, growing the largest eyes on Earth to serve it. In a place where there is almost nothing to see, the animal has built itself around seeing. That paradox is the key to understanding how it lives. The resolution is that almost nothing is not the same as nothing. The deep holds faint light, the cold sparks of bioluminescence, the glow triggered by movement, the dim signatures of living things flashing in the black. To an ordinary eye, these are invisible. To an eye the size of a dinner plate tuned to gather the faintest photons, they are a whole language of light written across the darkness. So the giant squid does not fight the darkness by giving up on sight. It fights it by making sight extraordinary, collecting every scrap of available light, with an organ so large and sensitive that it can read a world other eyes would find blank. Where other deep-sea animals lean on smell, touch, or the detection of vibration, the giant squid leans above all on its eyes. This shapes everything. The hunt depends on spotting prey or the glow it disturbs. Survival depends on catching the faint halo of an approaching whale. Orientation, timing, the decision to strike or flee, all of it flows first and foremost through vision. The animal is in a real sense defined by its eyes. In the largest dark habitat on the planet, it made the improbable choice to be a creature of sight and then committed to that choice more completely than anything else alive. Why build an eye that large, though larger than the darkness alone seems to require? The leading idea is unsettling. The eye is for spotting the hunter, not the hunted. Return to the calculation from earlier. Scientists modeling deep-sea vision found that beyond a certain size, an eye offers little extra help in finding small prey. The improvement flattens out, and the added cost of growing a larger eye stops paying off. So the giant squid's plate-sized eye is for ordinary hunting, bigger than it needs to be. Something else must justify it. Their answer was the sperm whale. A hunting whale plunging through the deep disturbs the water and ignites the bioluminescent plankton around it, wrapping itself in a faint, spreading glow. Detecting that glow at a distance would take an exceptionally large eye, and at the giant squid's enormous eye size, and essentially only there. The researchers calculated the animal could catch that whale signal from far enough away to react and flee. This is the predator detection hypothesis, and it flips the whole picture of the eye. The giant squid's greatest sensory investment may be aimed not at securing its next meal, but at avoiding becoming one. The eye is a watchtower scanning the dark for the approach of the one predator large enough to swallow it whole. Scientists still debate it. It remains a hypothesis, mathematically elegant, consistent with what is known, but not directly proven, and surely not the only force that shaped the eye. Other pressures likely contributed. Certainty here is hard to come by, as it so often is with this animal. But the idea reframes the giant squid in a haunting way. That vast staring eye, the largest in the living world, may exist, chiefly out of fear, a lifelong watch kept against the whale built by the deep into an organ the size of a plate. Look closer at the eye itself, and its sensitivity borders on the miraculous. It is built to catch light almost down to the single particle. At the back of that dinner plate eye lies a retina packed with light-sensitive cells arranged to capture as many photons as the dim deep will surrender. The whole organ is an exercise in light gathering pushed toward its physical limits, a wide aperture to let light in a large retina to catch it, and a sensitivity tuned for a world where photons arrive not in floods but in trickles. In the deep, light is not measured in brightness but in scarcity. A patch of ocean 1,000 meters down might offer only the faintest, rarest glimmers, a distant bioluminescent flash, the cold light stirred up by a moving body. An eye that hopes to see anything there must be able to register vanishingly small amounts of light, catching individual photons where they fall. The giant squid's eye is built for exactly that regime. Its enormous size is not about seeing fine detail or sharp images. It is about raw sensitivity gathering enough of the deep's meager light to detect that something is there, and roughly where, and roughly how it moves. In the dark, detection matters more than definition. Knowing a shape is present beats seeing it clearly. There is a trade buried in this. A larger eye gathers more light, but demands more of the body to build and maintain more tissue, more energy, more space in the head. The giant squid paid that price to an extreme degree because in its world the payoff was survival itself. Better vision meant earlier warning of the whale, and earlier warning meant life. The result is one of the most sensitive, light-catching organs evolution has ever produced, a retina straining to read a nearly dark world photon by scarce photon. Seeing is not enough in the deep. An animal also has to know which way is up, and the giant squid solves that with a pair of tiny internal organs called statocysts. Down where the giant squid lives, there is no light to orient, by no visible surface, no seafloor in view, just open black water in every direction. In that featureless dark, a body could easily lose track of its own posture, unable to tell up from down level, from tilted. The statocysts prevent that. They are the animal's sense of balance and orientation, its internal compass for the vertical world. Each statocyst is a small, fluid-filled chamber containing a dense mineral grain and lined with sensitive hairs. As the animal tilts and turns, gravity pulls the grain, and it presses against different hairs depending on the body's orientation, telling the squid moment to moment which way is down. It is the same basic principle that the balance organs in your own inner ear use to keep you upright. This matters enormously for a hunter that hangs suspended in open water. To hold a steady ambush position, to strike accurately, to jet away in a controlled direction rather than tumbling blindly, all of it requires knowing the animal's own attitude in space. The statocysts supply that knowledge continuously in total darkness with no external reference needed. They pair naturally with the eyes. Vision tells the giant squid what is out there in the water. The statocysts tell it how its own body is arranged relative to gravity. Together, they let the animal operate with precision in a place that offers almost no cues to work from, a dark, open void where every direction looks the same. Small organs easy to overlook beside the spectacular eyes. But without them, the giant squid would hang disoriented in the black, unable to trust which way was up. Inside the giant squid's brain, the priorities are written in raw tissue. A huge share of it is devoted to sight. The optic lobes, the parts of the brain that process visual information, are strikingly large in the giant squid matched to the enormous eyes they serve. Feeding an eye the size of a dinner plate requires a great deal of neural machinery to handle the flood of information it collects, and the giant squid's brain reflects that, dedicating outsized real estate to vision. The eyes are big. The brain regions behind them are big to match. This is how a nervous system reveals what an animal cares about. Brain tissue is costly to build and run, and evolution does not lavish it on senses that do not earn their keep. When a large fraction of the brain is given over to processing sight, it means sight is central to how the animal survives, worth the enormous investment of neural resources. In the giant squid, that investment is unmistakable. The optic lobes loom large, dominating the brain much as the eyes dominate the head. Vision is not one sense among many for this animal. It is the sense around which the whole nervous system is organized, the primary channel through which it reads its world. It fits everything already established. The plate-sized eyes, the photon-catching retina, the possible watch for the whale's glow, all of it demands heavy processing, and the brain supplies it. The hardware of the eye and the software of the optic lobes are built to the same grand scale, two halves of a single commitment to seeing in the dark. So even inside the skull, the giant squid tells the same story. This is an animal that bet its survival on vision and reshaped its brain to honor the bet, turning a great share of its mind over to the single task of making sense of a nearly lightless world. Here is where the giant squid's brain becomes truly alien. It is shaped like a ring, and it is wrapped around the animal's throat. Unlike a vertebrate brain tucked into a protective skull, the cephalopod brain encircles the esophagus, the tube carrying food from mouth to gut. The main mass of nervous tissue forms a ring, and the gullet runs straight through the hole in its center. The brain is not above the throat or behind it. It is around it. This is one of the strangest arrangements in animal anatomy, and it has a direct, almost comical consequence. As established earlier, everything the giant squid swallows must pass through the middle of its own brain on the way to its stomach. The animal quite literally eats through the center of its mind. Food threads the donut of nervous tissue with every meal. The design constrains the animal in real ways. Because the esophagus runs through the brain ring, the giant squid cannot swallow large, unbroken chunks. Anything too big would press dangerously on the surrounding neural tissue. This is why the beak and radula must first cut and rasp prey into small pieces. The food has to be reduced to a size that can safely pass through the hole in the brain. It is a vivid reminder of just how far the cephalopod body plan diverges from our own. Nature, given the same basic problems, arrived at a solution no vertebrate ever would, a brain built as a collar around the gullet, thinking and swallowing routed through the same central point. Picture it plainly. At the very heart of the giant squid, where all the arms converge, sits a ring of brain with a throat running through it, the mind and the mouth fused into a single strange structure, unlike anything in the world we know. Sit with that arrangement a moment longer because its logic runs deep. Every meal the giant squid eats passes through the middle of its brain, and that fact shapes the entire hunt. Trace the chain backward from the swallowing. Because the throat threads the brain, food must be small and smooth to pass safely. Because food must be small and smooth, the beak and radula exist to cut and rasp it. Because the prey must be brought to the beak, the arms haul it inward. Because the prey must be caught in the first place, the tentacles strike. The whole elaborate hunting sequence traces back in part to one anatomical fact at the center of the animal, a brain wrapped around the gullet. It is a striking example of how a single structural quirk can ripple outward through an entire way of life. The giant squid does not process its food into small pieces by preference or habit. It does so out of necessity because its own anatomy forbids swallowing anything large, and that necessity has shaped the design of its mouth, the roll of its limbs, and the very strategy of its hunt. There is something almost poetic in it. The animal's intelligence and its appetite are physically intertwined, routed through the same central ring. It cannot eat without, in a sense, passing its meal through its mind. The two most basic drives of any animal, to think and to feed, meet at a single point in the giant squid's body. This is what makes the creature such a profound departure from the familiar. It is not merely large or strange-looking or hard to find. It is built on organizing principles so different from our own that even the relationship between its brain and its stomach follows rules we would never have guessed. The giant squid eats through its brain, and everything about how it hunts bends to accommodate that single alien truth. Even in the dark, the giant squid can change its color. Its skin is studded with cells that shift its appearance at will. Like other cephalopods, the giant squid carries chromatophores, tiny pigment-filled sacs embedded in the skin, each surrounded by muscles that can stretch it wide or pull it tight. Expanded, a chromatophore spreads its pigment across a patch of skin and darkens it. Contracted, it shrinks to a dot and lets the color beneath show through. By controlling thousands of them, the animal can alter its coloration across its body. In the well-lit world of shallow-water cephalopods, this ability produces dazzling displays, octopuses and reef squid flashing patterns for camouflage and communication. In the giant squid's dark deep, its exact use is harder to know since there is little light to display color by. But the machinery is there, and the animal can shift its appearance, reddening or paling its skin as octopuses and other squid do. Why keep such an ability in a place with almost no light? Scientists are not entirely certain. Perhaps it matters in the faint glow of bioluminescence, where even dim color changes might register to another animal's sensitive eyes. Perhaps it plays a role in interactions between squid at close range. Perhaps it is partly a holdover from shallower living ancestors. The honest answer is that the function in the deep is not fully understood. What is clear is that the giant squid is not a fixed, static colored thing. It is capable of change its skin, a responsive surface, rather than a dead one able to shift its shade in the dark, for reasons we can only partly guess. One more layer of sophistication in an animal that keeps proving more complex than its monster reputation ever suggested. A creature that can, even in the lightless deep, change the color of its own skin. Put the propulsion and the control together, and the giant squid turns out to be a surprisingly capable pilot of its own body. It steers in 3 dimensions with funnel and fins. The funnel provides the primary steering. Because that flexible tube can swivel and point in different directions, the squid can aim its water jet, and by aiming the jet, it directs its thrust, turning and maneuvering as it moves. Point the funnel one way, shoot off the other. It is thrust vectoring, the same trick that lets certain aircraft change direction by angling their exhaust. The fins add finesse. Along the mantle, the giant squid carries fins that it uses for slower, more controlled movement, and for fine adjustments to its position, gentle sculling to hold station or glide, as opposed to the hard jet used for bursts of speed. Between the fins for delicate control and the funnel for powerful thrust, the animal commands a full range of movement, from a slow hover to an explosive escape. This combination gives the giant squid real command of the open water column, where there is no ground to walk on, and movement must happen freely in every direction, up, down, and all around. It can hold a steady ambush position, adjust its orientation to face prey or threat, and launch itself away at speed when danger appears. For an animal that lives suspended in a 3-dimensional void, that control is essential. It also refines the picture of how the animal hunts and survives. The still patient hover of the ambush is fin work, quiet, precise holding position. The sudden strike and the sudden flight are funnel work, the hard jet unleashed. The same animal moves gently and violently as the moment demands switching between its two modes of motion. Neither a drifting hulk nor a clumsy giant, the giant squid pilots itself through the black with a control that its soft, ammonium-laden body might never lead you to expect. For all that anatomy, the animal stayed unseen alive until almost yesterday. The breakthrough came in 2004, and it came from thinking differently. Two Japanese researchers had grown convinced that the old approach was doomed. Chasing the giant squid with crude submersibles, bright lights, and loud engines had failed for decades, most likely because those very intrusions frightened the animal away before anyone could see it. So they inverted the method. Instead of going down to find the squid, they would set bait hold still and let the squid come to them. They lowered a long line, more than 900 meters down into the deep water off Japan's Ogasawara Islands, where sperm whales were known to hunt, reasoning that where the whales fed the squid must live. They baited it, rigged an automatic camera to fire on its own at intervals, and waited in the dark, patience in place of pursuit. The patience paid off. A giant squid rose out of the black and attacked the bait, and the camera fired again and again, capturing more than 500 images over about 4 hours as the animal struggled against the line. Its feeding tentacles lashed and gripped. At one point, a tentacle tore away and was left behind, still coiled around the bait when the squid finally wrenched free. These were the first images ever taken of a living giant squid in the wild. Not a corpse, not a stranded ruin, but a healthy animal hunting in its own dark world. After centuries of studying, only the dead humanity finally had a living giant squid on record. And the pictures rewrote the animal. The strike was fast and forceful, the behavior aggressive, the sluggish drifter of old assumption replaced in a few hundred frames by the active predator the giant squid truly is. One clever change in method, and the invisible animal finally showed its face. Photographs were one thing. Moving footage of a living giant squid took another 8 years, and a small submersible waiting in the dark. 2012. A team of Japanese and international scientists set out to do what no one had done: film a giant squid alive in its own deep world. They had absorbed the lesson of the past. Bright lights and noisy engines drove the animal off, so this expedition went quiet and it went dark, descending in a cramped submersible built to hold up under the pressure of the deep. Stealth. This time, instead of spectacle, they used lights tuned to a color the squid could barely detect so the animal would not be startled by the glow, and they carried bait to draw it near. Then they sank into the black water south of Japan and waited, hanging in the dark, hundreds of meters down, watching. At around 630 meters it came. A giant squid rose into the faint, near-invisible light and approached its arms, spread its great eye, catching the glow, its body holding steady with a poise no corpse had ever hinted at. And the cameras rolled. For the first time in human history, a living giant squid moved across a screen filmed in the deep where it lived. The scientists aboard were overwhelmed. One had spent much of a career chasing this exact moment, and here it finally was, the animal itself, alive, deliberate, hanging in the beam, and regarding the strange machine that had come to find it. A lifetime of searching resolved into a single encounter in the dark. The footage did what the photographs began. It turned the giant squid from legend into living animal, from rumor into a creature you could watch, breathe, and move. After all the centuries of corpses and myth, humanity could finally see the monster do the one thing no dead specimen could show: simply be alive. The trick that finally lured it into frame deserves its own telling. They drew the giant squid in with a glowing decoy. Alongside conventional bait, the 2012 expedition deployed something cleverer: a lure designed to mimic bioluminescence, a device that produced a pattern of light imitating the glow of a certain deep-sea jellyfish. That jellyfish, when attacked, puts on a spinning display of light, sometimes called a burglar alarm, a flashing distress signal that can attract larger predators, drawing in something big enough to threaten whatever is attacking the jelly. The lure faked that alarm. The logic was subtle. Rather than simply offering food, the researchers offered a signal, a light show, that in the language of the deep meant a struggle was happening and a meal might be near. To a large predator, like the giant squid, that flashing pattern was an invitation, a promise of prey drawn out by the commotion. The decoy spoke the animal's own visual language. And it worked. Attracted by the glowing lure, the giant squid came in close enough to be filmed, the fake distress signal succeeding where brute searching had failed for decades. Human ingenuity had learned to speak, however crudely, in the flashing light tongue of the deep, and the animal answered the call. It is a striking meeting of worlds. For centuries, the giant squid eluded every direct attempt to find it. In the end, it was coaxed into view, not by force, but by trickery, by a machine that mimicked the light of a frightened jellyfish and exploited the squid's own hunting instincts against it. The animal that hid from humanity for all of history was finally drawn out by a clever imitation of a light it already knew, lured into the camera's eye by a signal that whispered in the dark that dinner might be close. The giant squid is a creature of the world's deep oceans, but in 2019 it surfaced on film somewhere new. The Gulf of Mexico. A team of American scientists working in deep waters of the Gulf was using a specialized camera system designed for exactly this kind of quiet, non-intrusive observation. Like the earlier successes, the approach relied on stealth and on an optical lure that imitated bioluminescence, the same fake jellyfish distress signal that had worked so well before, refined and deployed again in a new sea. And again, a giant squid answered. Drawn by the glowing decoy, one came into the camera's view, captured in footage from the Gulf of Mexico, a demonstration that these animals lived in the deep waters there too, not only in the distant Pacific off Japan. The giant squid was not confined to one exotic corner of the ocean. It was closer to home than many had realized. The footage carried weight beyond the sighting itself. It confirmed that the lure and stealth method was repeatable, that the 2012 triumph had not been a one-off stroke of luck, but a genuine technique, one that could be carried to new waters and used again to coax the elusive animal into view. A method, not a miracle. It also expanded the known reach of the animal in the human imagination. A giant squid off Japan is a creature of a faraway deep. A giant squid in the Gulf of Mexico is a neighbor hunting in waters bordered by familiar coastlines. The monster of legend turned out to live quietly much nearer than the legend implied. 3 encounters. Now the photographs, the first film, and the Gulf footage, each one built on the same insight. Stop chasing, start waiting, and speak to the animal in light. Slowly, sighting by sighting, the giant squid was being pulled out of the dark. How do you tell the age of an animal you can barely find alive? For the giant squid, the answer is hidden in a tiny stone inside its head. You read its growth rings. Deep in the giant squid's body, as part of its balance organs, sit small, hard structures called statoliths, the dense mineral grains of the statocysts, the same organs that tell the animal which way is up. As the squid grows, these statoliths grow too, laying down material in fine layers over time. And crucially, they lay it down in rings. Those rings are thought to form at regular intervals, quite possibly one per day, much like the growth rings in a tree, but on a far shorter timescale. By slicing a statolith and counting its microscopic layers under a microscope, scientists can estimate how many of those intervals the animal lived through, and therefore roughly how old it was when it died. A stone the size of a grain, holding a calendar of the animal's life. This is how researchers arrived at one of the most astonishing facts about the giant squid, its age. When they counted the rings, the numbers came back shockingly low. This enormous animal, the stuff of centuries of legend, turned out not to be the ancient, slow-growing leviathan everyone had imagined. The statoliths told a very different story, one the next facts will unfold. There is something wonderful in the method itself. An animal that eluded direct observation for all of human history could still be made to give up the secret of its age not through watching it live, but through reading the tiny mineral clock it carried inside its own head. Count the rings, and the giant squid confesses how long it lived. The answer would overturn one of the oldest assumptions about the monster of the deep. For over a century, scientists could not agree on how many kinds of giant squid there were. Then DNA delivered a stunning verdict. There is only one. Recall the confusion. Over the years, giant squid specimens from different oceans had been given different species names at one point. A whole crowd of them, more than 20 proposed species of Architeuthis, scattered across the scientific literature. Each new stranding from a new stretch of sea seemed to describe a slightly different animal, and the genus became a tangle of names that no one could sort out. Then, in a major study published in 2013, researchers gathered genetic samples of giant squid from around the world, from oceans separated by vast distances, and read their DNA. If there really were many species, the genetics would show clear divisions, distinct groups separated by deep genetic differences. That is not what the DNA showed. Instead, the giant squid samples from across the entire planet turned out to be remarkably alike, genetically so similar that the study concluded they very likely represent just a single species, one kind of giant squid living in deep oceans all over the world. The crowd of proposed species collapsed into one. Architeuthis, it appeared, was a single global animal. This was a profound simplification. The monster that had seemed to come in many regional forms was genetically one creature with a worldwide range, the same species haunting the deep off Japan, off Europe, off the Americas, off New Zealand. One squid, one ocean-spanning population, wearing the mask of many. The finding closed one of the oldest arguments about the animal, and it opened a new mystery in the same stroke. For if giant squid across the whole world are so genetically alike, something must be keeping them mixed together, and that something, as the next fact shows, is a puzzle all its own. That single species result came wrapped in something even stranger. The giant squid shows remarkably little genetic variation. Worldwide, they are almost eerily alike. Normally, a species spread across the entire globe accumulates differences from place to place. Populations in distant oceans, separated by thousands of miles, tend to drift apart genetically over time, developing distinct regional signatures, the mark of groups that rarely interbreed. The giant squid does not follow this pattern. The genetic study found strikingly low diversity, with individuals from far-flung oceans nearly identical in the DNA examined. This is genuinely puzzling, and scientists are still working to explain it. Low genetic variation across a global range suggests that giant squid everywhere are mixing, that the population is not fragmented into isolated regional groups, but somehow stays connected as a single interbreeding whole, spanning the world's deep waters. But how? How does a population maintain such unity across entire oceans? One leading idea points to the animal's early life. Giant squid begin as tiny larvae, paralarvae, drifting in the water, and these young stages, along with ocean currents, may carry the animal's genes across enormous distances, mixing the global population before the squid ever descend into the deep. The larva, riding the currents, could be the threads that stitch the species together worldwide. It remains an open question, one of many surrounding this animal. The low diversity is a real and measured finding. The full explanation for it is still being worked out. Researchers continue to debate exactly how a globe-spanning deep-sea animal stays so genetically uniform. It is a fitting mystery for the giant squid, an animal that turns out to be a single kind spread across every deep ocean and bound together so tightly by some hidden mechanism that individuals half a world apart are nearly the same in their heinous. Beyond simply proving the animal alive, the footage taught scientists something they had never been able to watch: how the giant squid actually moves. For all the centuries of studying corpses, movement was the one thing the dead could never reveal. A carcass shows anatomy but not behavior, the shape of a fin but not how it sculls, the length of a tentacle but not how it strikes. Only living footage could show the animal in motion, and when it finally arrived, it corrected long-held assumptions. The old picture had the giant squid as a passive drifting thing, a sluggish hulk hanging limp in the deep, waiting for food to blunder into its arms. The footage overturned that. The living animal was poised and controlled, holding its position with deliberate command, moving with intent rather than drifting at the mercy of the current. It approached the bait purposefully. It handled itself with precision. The films revealed the interplay of the animal's movements, the way it held station in the water, the way it oriented its body and arms toward a target, the coordination of a creature actively piloting itself through the dark, rather than passively floating in it. This was not a monster lolling in the deep. It was a predator in command of its body. Each piece of footage added detail. The strike of the tentacles, the fanning of the arms, the steady hovering, the turn toward prey behaviors that no corpse could ever have demonstrated, now visible for the first time. Slowly, the living animal filled in the enormous blank that the dead ones had left. It marked a turning point in understanding the giant squid, the shift from knowing its body to knowing its behavior, from a catalog of parts to a portrait of a living, moving, self-directed animal. The monster at last was seen to move. Now hold the whole animal up against something familiar, because the numbers alone do not land until you can picture them. Laid out to its full length, a giant squid runs about as long as a school bus. The largest well-documented individuals reach roughly 13 meters from the tip of the mantle to the ends of the outstretched feeding tentacles, and that is very nearly the length of a standard American school bus front bumper to rear. Picture the bus that carried children to school, and then picture a single living animal stretched out to match it, hanging in the dark ocean. Let that image sit. Not a whale, which we expect to be huge, but a squid, a relative of the little calamari rings on a dinner plate grown to the length of a vehicle that seats 40 children. The same basic body plan as a creature you could hold in one hand, scaled up until it spans a school bus. The comparison also carries the earlier honesty about the animal's build. Much of that bus length is reached, the two long feeding tentacles stretched to their limit, while the muscular body itself is far shorter, only about the length of a tall man. So the giant squid is not 13 meters of solid bulk. It is a modest body trailing enormous limbs, the whole assembly spanning the length of a bus when fully extended. Still, the image does its work. It takes a number that means little on its own and turns it into something a person can stand beside. In the mind, a school bus, familiar and enormous, and an animal in the deep that matches it end to end. That is the scale of the thing hanging in the dark. Longer than the bus, alive, and until this century entirely unseen. Move from the whole animal to a single part, and the scale stays staggering. The giant squid's eye is larger than a human head. Each of those eyes measures close to a foot across, roughly the size of a dinner plate and comfortably wider than an adult human skull. Set a person face to face with the animal, and a single one of its eyes would be bigger than that person's entire head, a vast dark orb gazing back out of the dark. The comparison is almost hard to accept. We think of eyes as small things, a marble, a coin at most, the modest eye of a large mammal. The giant squid shatters that expectation. Its eye is not measured against other eyes, but against skulls, plates, and spans of a hand. It is the largest eye known in the history of life, and it belongs to this animal. Hold your own head in your hands for a moment and consider the scale. That whole volume, skull, brain, face, and all, is smaller than one of the giant squid's eyes. The animal carries two of them, one on each side, each larger than the head of the human, straining to see it in the beam of a submersible. And the size as established is not vanity. It is survival, an organ grown to this extreme to gather the deep, scarce light, and perhaps to catch the distant glow of a hunting whale. The eye is huge because the darkness demanded it, and the giant squid answered with an eye beyond anything else alive. Picture it one more way. Two dark eyes, each wider than your head, set into the front of an animal, as long as a bus, watching from the black water. That is the giant squid seen up close, a face built around the largest eyes on Earth. Shrink the focus one more step down to the single hard point at the animal's center. The beak of a giant squid could close on a human hand. At the hub of all those arms sits the beak, that hard, sharp, parrot-like structure of black chitin, the animal's one rigid weapon. In the largest giant squid, it is a formidable size, easily big enough to take a human hand within its jaws, with edges built to shear through flesh and cutting force to match. It is small, next to the vast body, but it is the business end of the whole animal. Consider the contrast. An animal as long as a school bus, with eyes larger than your head, and at its very center, a cutting beak scaled to close over your hand. The giant squid is enormous, but its lethality is concentrated in this one compact, hardened point, where everything the tentacles catch is finally cut apart. This is the part, remember, that survives in a sperm whale's stomach when all the soft flesh has dissolved, the indigestible black beak found by the thousands, the first hard proof that the deep teemed with these animals. The one piece, tough enough to outlast the whale's digestion, is the same piece built to butcher the squid's own prey. There is no need to overstate the danger to people. The giant squid lives far below where any swimmer goes, and encounters are essentially non-existent. But the beak makes the animal's nature plain. This is a predator equipped at its core with a tool for cutting flesh, a hard, sharp instrument at the heart of a soft and enormous body. Bus-length body, dinner plate eyes, and at the center a beak that could take a hand. Piece by piece, the scale of the giant squid resolves into something the mind can finally hold, and it is every bit the monster the legends reached for, if not in temperament, then in sheer astonishing size. One more measure completes the picture of scale. At their largest, giant squid approach the weight of a ton. The heaviest well-documented individuals, the great females, which outgrow the males, are estimated to weigh in the neighborhood of 1,000 pounds, and possibly more, approaching the mass of a small car. This is the animal at its most massive, not just long, but genuinely heavy, a substantial bulk of muscle organ and waterlogged flesh hanging in the deep. Hold the full set of numbers together now, as long as a school bus, eyes larger than a human head, a beak that could close on a hand, and a weight in the largest nearing that of a small automobile. Each measure alone would be remarkable. Together they describe one of the most impressive animals in the ocean. The weight comes with the same caveat as the length. Much of the giant squid's mass is soft, ammonium-laden, water-heavy tissue, rather than dense athletic muscle, the buoyant flesh that lets it hover in the deep. So, it is heavy, but not in the way a solid ton of muscle would be. It is a large, soft, waterlogged body, massive on the scale, but not built for brute power. Still, the figure lands. A single squid weighing what a small car weighs, stretched as long as a bus, with eyes like dinner plates, the arithmetic of the animal keeps arriving at the same conclusion. This is a giant in every dimension that can be measured: length, weight, and the size of its individual parts. The females again are the true heavyweights. The largest, heaviest giant squid on record are female, dwarfing the males in both length and mass, a pattern that points ahead to the animal's strange reproductive life, where the difference between the sexes runs deeper than size alone. That reproductive life begins with a number almost too large to picture. A single female giant squid can carry millions of eggs. Inside a mature female lies an enormous reproductive capacity, an egg mass estimated to hold well over 1 million eggs, and by some accounts, many millions, each one tiny, packed together in a vast gelatinous body carried within the animal. For a single creature to produce eggs by the million places, the giant squid among the most prolific animals in the sea. Set that against a familiar scale, and it strains belief. 1 million of anything is hard to hold in the mind, a crowd filling a stadium many times over. The giant squid carries that many potential offspring, and more as a single internal mass, a reservoir of future squid numbering in the millions inside one female's body. There is a hard logic to the extravagance. The open ocean is a merciless nursery. The overwhelming majority of those millions of eggs and the tiny larvae that hatch from them will never survive, picked off by predators, lost to the current, starved before they grow. To beat those odds, the giant squid plays a numbers game of staggering scale release. So many young that from millions, at least a few survive to adulthood. It is a strategy of abundance over care. The female does not nurture a handful of young to safety. She floods the ocean with vast numbers and lets the brutal arithmetic of the sea do the rest, trusting that out of millions enough will endure to carry the species forward. Millions of eggs in a single animal. It is the giant squid's answer to a lethal ocean and the beginning of a reproductive story that grows stranger with every step, starting with how those eggs come to be fertilized in the first place. How those millions of eggs get fertilized is one of the giant squid's stranger secrets. The male implants his sperm directly into the female's flesh. In the giant squid, the male does not simply release sperm near the eggs. Instead, he transfers packets of sperm, spermatophores, and these are implanted into the female's body, embedded in the tissue of her arms or mantle, apparently injected or driven into the flesh itself. The male's sperm packets are lodged directly within the female, held in her body until the eggs are ready. The exact mechanism remains poorly understood because, like so much of this animal's private life, it has almost never been observed. Scientists have found evidence of it in examined specimens, spermatophores embedded in female tissue, but the act itself, the actual mating of giant squid, has essentially never been witnessed. What is known comes from the aftermath. Read in the bodies of captured or stranded animals. The male's equipment suits the task. Giant squid males possess a very long reproductive structure well suited to reaching and implanting spermatophores into the female's body, an anatomy built around this particular method of sperm transfer. The design points clearly to the behavior, even though the behavior itself hides from view. It is a reproductive strategy, unlike the familiar ones, and a fittingly mysterious one for such an elusive animal. Somewhere in the deep dark giant squid meet and mate by this strange method of implantation, and then part the female carrying the male's embedded sperm packets within her flesh until her millions of eggs are ready to be fertilized and released. Almost nothing about that encounter has ever been seen. The method is inferred from bodies not observed in life, one more chapter of the giant squid's existence written in the dark beyond the reach of any camera. When the eggs are finally released, they come as a single vast structure. The female produces an enormous floating mass of eggs held together in jelly. Rather than scattering her millions of eggs loose into the water, the female giant squid is thought to extrude them, bound together in a huge gelatinous egg mass, a great ribbon or cloud of jelly with the tiny eggs embedded throughout, released into the open water of the deep. This egg mass is large, in keeping with the millions of eggs it holds, a substantial body of jelly drifting in the sea. Direct observation of a giant squid egg mass in the wild is extraordinarily rare. Again, the animal guards its reproductive life from view. But from related squid and from what has been pieced together, scientists picture the female releasing this immense jellied mass, the eggs suspended within it, floating in the deep water while the embryos inside develop toward hatching. The jelly serves a purpose. It holds the eggs together, may help protect them, and keep them suspended at the right depth, and cradles the developing young in a buffered, watery matrix as they grow toward the moment of hatching. The mass is a floating nursery, drifting in the dark with the next generation forming inside it. Picture it hanging in the black water, a great translucent cloud of jelly shot through with millions of minute eggs suspended in the deep ocean where no light falls. Somewhere in the world's deep waters at this very moment, such masses may be drifting unseen, each one carrying a future generation of giant squid toward its improbable start in life. And when those eggs hatch out, comes the least monstrous version of the monster imaginable, a creature so small it would rest on a fingertip, the tiny beginning of an animal that will one day rival a school bus. The animal that eventually rivals a school bus begins life almost invisibly small. A newly hatched giant squid is only a few millimeters long. The hatchling, called a paralarva, emerges from its egg as a minuscule creature, just millimeters in length, small enough to sit on a fingertip with room to spare. It is a perfect tiny squid, complete with its little arms and eyes and funnel drifting in the water as a speck among the plankton. Nothing about it suggests the giant it may become. Consider the span of that transformation. From a few millimeters at hatching to as long as 13 meters at full size, the giant squid grows from something you could barely see to something as long as a bus. It is one of the most extreme-sized journeys in the animal kingdom, a creature that begins life as a fleck and ends it as a leviathan. The tiny paralarva lives at first in the upper waters, drifting among the ocean's smallest inhabitants, feeding and growing in the plankton-rich layers nearer the surface. At this stage, it is not a monster at all, but prey, one of countless minuscule drifting things vulnerable to almost everything, most of which will not survive. This is why the millions of eggs matter. From that vast number of tiny hatchlings, the ocean will take the overwhelming majority. Only a rare few of these millimeter-long specks will run the gauntlet of predators and hunger and chance to grow toward adulthood. The giant begins as one of millions of the smallest, most fragile creatures in the sea, Hold the two ends of that life together, a hatchling on a fingertip and an adult as long as a school bus. Between them lies a growth story so fast and so extreme that it overturned everything scientists once assumed about how this animal lived. And that story is the next astonishment. The leap from fingertip to school bus does not take decades. It takes only a handful of years. The giant squid may grow to full size in roughly 5. This was the great shock hidden in the statolith rings. When scientists counted those tiny growth layers and estimated the animals' ages, the numbers came back astonishingly low, suggesting that the giant squid reaches its enormous size not over a long, slow lifetime, but in only about 5 years, perhaps even fewer. From a few millimeters to 13 meters, in the span of a small child's early life. Sit with how staggering that rate of growth is. To go from a speck on a fingertip to an animal as long as a bus in roughly 5 years, the giant squid must pack on size at a furious pace, one of the fastest, most extreme growth trajectories of any large animal. It does not creep toward its size. It rockets toward it. This overturned a deep assumption. Everyone had pictured the giant squid as an ancient, slow-growing creature of the cold deep, a leviathan that took decades, maybe a lifetime to reach its legendary size, aging slowly in the frigid dark. The statoliths said otherwise. This was no patient, long-lived giant. It was a sprinter achieving its enormous bulk in just a few frantic years. To grow that fast, the giant squid must eat prodigiously and convert food to body with remarkable efficiency, driving its size upward season after season at a rate that belies the cold, resource-poor world it lives in. The soft, waterlogged, rapidly built body suddenly makes more sense. It is flesh assembled in a hurry. 5 years more or less from fingertip to leviathan. The number reframes the entire animal, and it points toward an even starker truth about how briefly the giant squid lives at all. That furious growth carries a harsh implication. The giant squid lives fast and dies young. If the animal reaches its full enormous size in only about 5 years, then its whole life is correspondingly short. The giant squid is not the ancient decades-old creature of legend. It is a brief-lived animal blazing through its existence in a handful of years, growing explosively, living intensely, and dying young, its entire life compressed into a span shorter than many house pets enjoy. This is a classic strategy in the living world, though rarely at such a scale: live fast, grow fast, and burn out quickly. Rather than surviving slowly across many years, the giant squid pours everything into rapid growth and a short, intense life, reaching enormous size and reproductive maturity in record time before its brief candle gutters out. It reframes every corpse ever studied. Those stranded giants, some of them enormous, were not ancient elders of the deep that had lived for decades. They were animals only a few years old, young in calendar terms, despite their tremendous size. The monster that seemed like it must be old and slow was in truth fast and fleeting. There is a strange poignancy in it. An animal that grows to rival a school bus, that carries the largest eyes on Earth, that haunted human legend for millennia, and it exists as an individual for only a few brief years. It arrives, grows with astonishing speed, and is gone its whole life, a short, bright rush through the dark. The giant squid, it turns out, is not a creature of deep time in its individual life. It is a creature of urgency, built to grow enormous fast, live briefly, and make way quickly for the next generation. And the way it makes way is the starkest part of all. The end of that short life is bound to a single act. The giant squid appears to breed once and then die. Like many squid, the giant squid is thought to be semmelporous, to reproduce a single time in one great reproductive effort and then perish. The whole of its fast, brief life builds toward that one event, grow enormous with all possible speed, reach maturity, spawn once in a massive release of eggs or sperm, and die in the aftermath. One generation, one act of reproduction, one end. This casts the animal's entire existence in a stark light. Every furious month of growth, every prey animal caught and processed, every scarce photon gathered by those enormous eyes, all of it serves a single purpose: to reach that one moment of reproduction. The giant squid does not live to hunt or to endure. It lives to breed once, and having bred, its work is finished. For the female, that single event is the release of her millions of eggs, the vast gelatinous mass extruded into the deep. For the male, it is the implantation of his sperm packets into a female. And for both, this culmination marks the end. The reproductive act is the final act, and death follows close behind it. It is a life shaped entirely around a single climax. There is no long twilight, no years of adulthood after breeding, no second chance in another season. The giant squid spends everything on one reproductive throw, and then it has spent its brief, intense life resolving into that one decisive event and its immediate fatal aftermath. Grow fast, breed once, die young. That is the arc of the giant squid's individual life, compressed into a few short years in the dark. And the strangest thing of all is how little of that arc the growing, the mating, the dying humanity has ever actually seen. For all that we have finally glimpsed the living animal, its most intimate moment stays entirely hidden. The mating of giant squid has essentially never been observed. Consider what is known and how it is known. Scientists understand that males implant spermatophores into females because they have found the embedded sperm packets in examined bodies. They infer the method from anatomy and from aftermath. But the act itself, two giant squid meeting and mating in the deep, has, as far as the record goes, never been witnessed by human eyes or captured by any camera. This is a remarkable gap. We have now photographed the giant squid hunting, filmed it moving, drawn it into view with glowing lures. Yet the pivotal event of its entire life, the single reproductive act around which everything else is arranged, remains completely unseen. We know it must happen constantly somewhere in the deep. We have simply never caught it happening. The reasons trace back to everything about the animal. It lives in the vast, dark, hard-to-reach deep. It is elusive, and it seems wary of the machines we send down. And its mating may happen in places or at depths, or in ways that have so far kept it entirely beyond observation. Whatever the cause, the curtain has stayed closed on this most private chapter. So one of the most basic facts of the giant squid's biology, how exactly it mates, remains inferred rather than seen, reconstructed from bodies rather than watched in life. The animal guards this secret more closely than almost any other. Somewhere below right now, giant squid are meeting and mating in the dark, as they must for the species to persist. No human being has ever seen it. Of all the mysteries this animal still holds, its hidden mating may be the most stubborn, a central act of its life that the deep has never once let us witness. The secrecy runs further still. Not only the mating, but the spawning, the release of the eggs has never been filmed in the wild. The moment a female giant squid releases her vast gelatinous egg mass into the deep should be one of the most dramatic events in the animal's life. Millions of eggs bound in jelly, extruded into the black water in a single great reproductive act. And yet no camera has ever captured it. Like the mating that precedes it, the spawning of the giant squid has stayed entirely beyond human observation. What scientists know of it, they have assembled indirectly from the anatomy of females, from the eggs found within examined specimens, from comparison with related squid whose spawning has been better studied. The picture of the giant squid releasing its egg mass is a reconstruction pieced together from fragments, not a scene anyone has watched unfold. This deepens the strange emptiness at the center of the animal's life story. The two defining reproductive events, the mating and the spawning, are both invisible to us. We can describe the hunt, the body, the eyes, the growth, the death. But the very acts by which one generation gives rise to the next remain unseen, happening somewhere in the deep beyond the reach of every camera we have lowered. It leaves an enormous blank in the middle of what we know. The giant squid's whole fast, brief life bends toward reproduction, and reproduction is precisely the part we have never observed. The climax of the animal's existence plays out entirely offstage in darkness. No lens has yet penetrated at the right moment. Somewhere in the world's deep oceans, a female giant squid is releasing millions of eggs into the water, as females have done for as long as the species has existed. It has never been seen. The nursery of the giant squid and the act that fills it remain among the deepest of the animal's many unseen secrets. The young are as hidden as the mating that makes them. Juvenile giant squid are almost never seen. Between the tiny hatchling and the enormous adult lies a whole stage of life, the growing juvenile, the animal in mid-transformation, larger than a paralarva, but not yet a giant. And that stage is very nearly a blank. Juvenile giant squid are caught or observed only on the rarest occasions, so seldom that this middle chapter of the animal's life is among the least documented of all. Think about the strangeness of that gap. Scientists have studied hatchlings and they have studied adults, but the animals in between, the ones actively growing from speck toward leviathan, largely elude them. It is as if we had photographs of infants and of the elderly, but almost none of anyone in between. The middle of the giant squid's life story is missing. The reasons trace to where these juveniles must live and how they must move. As they grow, the young squid are thought to descend from the surface waters into the deeper, darker layers where the adults dwell, passing into exactly the realm that is hardest for us to observe. They are neither at the surface where they might be netted, nor reliably where our few deep cameras happen to look. So the giant squid grows up almost entirely out of sight. The furious years of growth that carry it from millimeters to meters unfold in a part of the ocean and a part of the life cycle that has stayed stubbornly beyond reach. We know the growth happens, and how fast from the statoliths. We have simply never watched it happen. The result is an animal known mainly at its two extremes, the tiny beginning and the enormous end, with the vast transformation between them hidden in the dark. The juvenile giant squid, growing furiously somewhere in the deep, remains one of the great unwatched stages of life in the sea. Go back to the very start of that hidden life, to the one stage we glimpse most often. The paralarvae, the tiny young drift in the upper waters of the ocean. When a giant squid hatches, it does not begin life in the deep dark where the adults live. It begins nearer the surface as a minuscule paralarva drifting in the sunlit and near-surface layers among the plankton and the ocean's smallest creatures. Here in the upper water, the tiny squid feeds and grows through its earliest, most fragile days. This early residence in the upper ocean is significant. It means the giant squid's life begins in a completely different world from the one it will end in, starting in the lit, warmer, plankton-rich shallows before eventually descending into the cold, dark deep. The animal effectively lives in two oceans across its lifetime, beginning in one and finishing in the other. The drifting paralarvae are at this stage part of the plankton themselves, tiny drifting things carried by the currents feeding on smaller organisms and vulnerable to a host of predators. Most will not survive. From the millions that hatch, the upper ocean takes the overwhelming majority, leaving only a scarce few to continue toward the deep and toward adulthood. Because they live nearer the surface, the paralarvae are among the more observable stages of the giant squid's otherwise hidden life, occasionally caught in nets that sample the upper waters, offering scientists a rare, direct look at the animal's youth. It is at this tiny drifting stage that the giant squid is least invisible. So, the leviathan of the deep begins as a mote in the sunlit shallows, drifting, feeding, growing one among the countless minuscule lives of the upper ocean, before the long descent into darkness that will carry the rare survivor toward its enormous destiny. That descent is one of the great journeys of the animal's life. As it grows, the young giant squid sinks from the sunlit shallows down into the dark. The paralarva begins near the surface. The adult lives hundreds of meters down in the cold and lightless deep. Between those two lives lies a migration in depth, the growing juvenile gradually descending from the upper waters into the darker layers below, moving from the world of light into the world of permanent night as it matures. It is a passage from one ocean to another, made not across distance but downward through depth. This descent tracks the animal's transformation. As the squid grows larger and leaves its fragile paralarval stage behind, it moves into the deeper realm where it will spend its adult life hunting the twilight and the darkness where sperm whales dive to feed. The change in address matches the change in the animal, from tiny surface drifter to large deep-water predator. The journey helps explain why the juveniles are so rarely seen. As they descend, they pass out of the surface waters where nets most often sample and into the deep zones that are hardest for us to observe, and they do so during the very stage of life that is already least documented. The descent carries them in effect out of our sight. It also completes the picture of the giant squid's two-world existence. It is born in the light, and it dies in the dark, and the great downward journey between the two is part of growing up. The animal ends its life, a creature of the deep, but it does not begin there. It has to travel down to become what it is. Picture the young squid sinking slowly through the water column over the course of its early life, leaving the sunlit surface behind, passing down through the fading blue into the black, descending toward the cold, crushing, lightless world, where it will grow enormous, hunt, breed once, and die. Somewhere in that deep world, the adults must gather to mate, but where no one knows. The giant squid's mating grounds have never been found. For the species to persist, giant squid must come together to reproduce males, finding females, spermatophores, implanted eggs, eventually fertilized and released. This happens constantly, somewhere in the world's deep oceans. And yet the places where it happens, the depths, the regions, the conditions under which giant squid gather and mate remain entirely unknown. No one has located the giant squid's breeding grounds. This is a striking absence. For many animals, science knows where reproduction occurs, the beaches where turtles nest, the rivers where salmon spawn, the gathering places where herds and flocks and schools converge to breed. For the giant squid, there is no such known place. The animal's rendezvous, wherever it is, has stayed completely hidden in the vastness of the deep. The mystery compounds the puzzle raised earlier by the genetics. Giant squid across the whole world are remarkably alike in their DNA, suggesting a single, well-mixed global population, which implies that individuals from distant oceans must somehow be brought into reproductive contact. But how and where that mixing and mating happens is unknown. The connection is real. The meeting place is invisible. Scientists can only speculate. Perhaps mating occurs at particular depths or in particular regions, or is spread thinly through the vast deep rather than concentrated in defined grounds. The drifting larvae and ocean currents may carry genes across the world even if adults never travel far. The honest answer is that the geography of giant squid reproduction is simply not known. So one of the most basic questions about the animal, where does it breed, has no answer. Somewhere in the deep, giant squid are gathering to mate as they must. We have never found the place, and for now the giant squid keeps the location of its nursery entirely to itself. One clear pattern does emerge from the animal's reproductive life. Female giant squid grow considerably larger than males. Across the species, the largest individuals are female. Females reach greater lengths and heavier weights than males, sometimes substantially, so the true giants, the record-setting specimens as long as a bus and approaching a ton, are the females. The males, while still large animals, run smaller. This difference between the sexes, with females outsizing males, is a consistent feature of the giant squid. There is a reproductive logic behind it, common in the animal world. A larger female can carry more eggs, and the giant squid female carries millions held in a great mass within her body. Greater size means greater reproductive capacity, more room for the enormous egg load that the animal's numbers game strategy demands. For the female, being big is directly tied to producing the vast quantity of young the species relies on. The males face different pressures. Their role centers on finding females and implanting their sperm packets, a task for which sheer size matters less than it does for egg production. Freed from the need to carry millions of eggs, the males remain smaller, investing their more modest bulk in a different part of the reproductive equation. This size gap ties back to the animal's whole life strategy. The giant squid grows fast, breeds once and dies, and for the female, growing especially large in that brief window means being able to release the greatest possible number of eggs in her single reproductive act. Her size is in service of her millions. So when the giant squid appears at its most monstrous, the very largest, heaviest individuals ever recorded, it is almost always a female that is being described. She grows to that enormous scale for a reason to carry and release the vast reservoir of eggs on which the future of the whole species depends. That whole strategy, grow enormous, grow fast, breed once, carries a steep price. The energy cost of such rapid growth must be immense. To go from a millimeters-long hatchling to a 13-meter adult in only about 5 years, the giant squid must build body tissue at a furious rate, and building body tissue takes energy, a great deal of it. The animal must find, catch, and process enough food to fuel one of the fastest growth trajectories of any large creature, converting prey into its own rapidly expanding bulk season after season. That demands a prodigious sustained intake of energy. This helps explain the animal's whole design as a predator. The efficient ambush hunting, the long-reaching tentacles, the fast strike, the processing line of beak and radula, all of it serves the constant pressing need to fuel explosive growth. The giant squid cannot afford to hunt poorly. Its very life strategy depends on gathering enough energy to grow enormous in a hurry. It also fits the soft, waterlogged, ammonium-laden body. Rather than investing scarce energy in dense, costly athletic muscle, the giant squid builds a lighter, cheaper kind of flesh, bulking up quickly and buoyantly, achieving great size without the full energetic price that dense muscle would demand. It is a way of growing large fast, without needing quite as much fuel as solid muscle would require. Even so, the demand is enormous. A body growing that fast is an engine running hot, burning through prey to feed its own expansion, driving relentlessly toward the size and maturity that its single reproductive act requires. The giant squid's life is energetically a sprint, a short, intense burst of growth, paid for by relentless hunting in the deep. Grow fast and pay for it in prey. The giant squid's astonishing size, reached in so few years, rests on a foundation of constant, efficient, energy-hungry predation in the dark. Gather all these hidden stages together, and a single truth emerges. Almost the entire life cycle of the giant squid takes place in an unseen nursery of the deep. Consider everything that remains beyond observation. The mating has never been witnessed. The spawning has never been filmed. The egg mass is virtually never seen in the wild. The juveniles are almost never observed. The breeding grounds have never been found. Stage after stage of the giant squid's life unfolds in a part of the ocean and a part of the life cycle that has stayed almost completely hidden from human eyes. We know this animal in the end, mainly through fragments and inference. We have the corpses, the beaks and whale bellies, the tiny paralarvae in surface nets, the statoliths counting out the years, the rare footage of adults drawn to a lure. From these scattered pieces, science has reconstructed a life story, but so much of that story has never actually been watched. It has been assembled, deduced, pieced together from what little the deep gives up. The giant squid then lives most of its life in a nursery we cannot enter. It is born in the light, descends into the dark, grows enormous mates, spawns and dies, and the great middle of that arc from the descent through the mating to the release of the next generation plays out in darkness. No camera has properly reached. The animal's most important moments are its least seen. There is a kind of grandeur in that hiddenness. In an age when so little of the natural world escapes our observation, the giant squid still conducts the essential business of its existence entirely out of view, growing, meeting, breeding, and dying in a vast dark realm that remains in the deepest sense unwatched. The nursery of the giant squid is the deep ocean itself. And for all our cameras and cleverness, we have still barely been allowed to look inside. Step back from the animal's private life to its place in the wider ocean, and one relationship towers over all the rest. The giant squid is the prey of the sperm whale. The sperm whale is the largest toothed predator on Earth, and it dives deep, far deeper than any other air-breathing hunter, down into the cold dark where the giant squid lives. And there, in the depths, it hunts them. The evidence is overwhelming, and old the beaks by the thousands in whale stomachs, the whole diet built around deep-water squid. Where the giant squid dwells, the sperm whale comes to feed. This is one of the great predator and prey relationships of the planet, a contest between two giants played out in a place no human eye can watch directly. On one side, the largest toothed predator, plunging into the deep and hunting by sound. On the other, the largest-eyed animal on Earth watching the dark for the whale's approach. The two are bound together in the deep hunter and hunted, on a scale unmatched almost anywhere in nature. It reframes the giant squid's own biology in a striking way. Recall the leading idea about those enormous eyes, that they may exist in part to detect the faint glow of an approaching sperm whale. If so, then the whale has shaped the squid's very anatomy, driving the evolution of the largest eyes in the living world as an early warning system against exactly this predator. The hunter's shadow is written into the prey's body. For all its size and menace, then the giant squid is not the top of its world. Above it, quite literally, dives a hunter, larger still, a whale that has been feeding on giant squid for as long as both have existed in a deep-sea contest older than any human memory. The monster of legend, it turns out, is itself hunted, and the hunter leaves marks to prove it. Those hunts leave evidence on the survivors. Sperm whales carry the scars of their battles with giant squid rings etched into their skin. On the bodies of sperm whales, particularly around the head, observers have long noted distinctive circular scars, round marks scored into the whale's skin. These are widely understood to be the marks of giant squid and their relatives, the impressions left by the toothed sucker rings of the squid's arms and tentacles gouged into the whale during the struggle of the hunt. The squid's grip, remember, is backed by rings of hard teeth, and those teeth leave their signature behind. Picture the encounter that makes such a mark. A sperm whale plunges into the deep and seizes a giant squid. The squid fights its arms and tentacles lashing onto the whale, hundreds of toothed suckers digging into the whale's skin, gripping desperately against the predator. In the struggle, those clawed suckers score the whale's flesh, leaving circular scars that remain long after the fight is over. These scars are a kind of written record of a battle no one witnessed. Each ring on a whale's skin is testimony that this animal descended into the dark and grappled with a giant squid. Physical proof of an encounter that took place hundreds of meters down, beyond any observer, marked permanently onto the survivor's body. The whale carries the story of the hunt on its own skin. There is something vivid in that image. The great whale surfacing to breathe, its head ringed with the circular scars of deep battles, each mark the ghost of a giant squid that fought back in the dark. The evidence of the contest between these two ocean giants rides up from the depths, written directly onto the hunter. We rarely see the battle, but we see its aftermath ring by ring on the bodies of the whales that win. If the sperm whale hunts it from above, the giant squid is itself a formidable hunter of the layer where it lives. It is a predator of the twilight and the dark. In the deep middle waters it inhabits, the giant squid is a major predator, a large active hunter preying on the animals of that realm, using its reaching tentacles and fast strike to catch fish and other squid in the dark. Below the reach of sunlight, in the vast open water where it hangs and waits, the giant squid is one of the significant hunters, taking its place among the predators of the deep. This is worth emphasizing against the animal's own status as prey. Yes, the sperm whale hunts the giant squid, but the giant squid is no passive victim drifting helplessly in the deep. It is a capable predator in its own right, equipped with formidable hunting tools and a lethal ambush strategy, feeding actively on the creatures that share its dark world. It hunts and is hunted both at once. Its position sits in the ocean's twilight zone, and the darkness below it, the mid-water realm that stretches between the sunlit surface and the distant seafloor. This is one of the largest habitats on the planet, and one of the least understood, and the giant squid is among its notable large predators, a major player in the food web of the deep open ocean. The picture that emerges is of an animal woven firmly into the fabric of deep-sea life, neither simply monster nor simply meal, but a predator that hunts the smaller animals of its realm, while being hunted in turn by the great whale. From above, a hunter with a hunter of its own. In the deep twilight, then, the giant squid holds a powerful place, reaching out through the dark to seize its prey, even as it watches that same dark for the descending glow of the one predator large enough to make a meal of it. Beyond the whale above and the prey below the giant squid is a link binding the deep food web together. It is a bridge in the ocean's dark economy. Consider what passes through the animal. The giant squid eats fish and other squid of the deep, taking in the energy those creatures hold. And in turn, it is eaten by the sperm whale, passing that energy upward to the largest toothed predator on Earth. The squid stands in the middle, receiving energy from the smaller hunters below it, and delivering it to the great hunter above. It is a conduit. moving the ocean's energy from one level to the next. This is the quiet, essential work that predators do in every ecosystem, and the giant squid does it on a grand scale in the deep. It takes the productivity of the midwater, the fish, the squid, the life of the twilight zone, and concentrates it into its own enormous body, which then becomes food for the whales that dive down to hunt it. Through the giant squid, the deep feeds the surface-breathing giants above. Remove it and the web would be poorer for the loss, a major predator gone, and a major food source for the sperm whale vanished with it. The giant squid is not a curiosity at the edge of the ocean's life. It sits woven into the center of the deep-sea food web, a substantial link connecting the layers of that vast dark world. So, the monster of legend turns out to have a role as ordinary in its way as it is grand. It is part of how the deep ocean works, a piece of the machinery that moves life and energy through the largest habitat on the planet. And in that unseen economy of the dark, the giant squid is not a monster at all, but a vital working part of a living system far larger than itself. Look more closely at what fills that role, at what the giant squid actually eats. Its diet is fish and other squid. From studies of stomach contents and from what is known of the animal's habits, the giant squid's prey appears to be primarily deep-sea fish and other squid, including at times other giant squid. It is a hunter of the mid-water, taking the swimming animals of its realm, seizing them with its reaching tentacles and cutting them down at its beak. Fish and squid, the staples of a deep-sea predator's table. That last detail carries a dark note. The giant squid may on occasion prey on its own kind, cannibalism, of the sort seen in a number of squid species where the large and hungry do not spare their smaller relatives. In the competitive dark, another giant squid is not necessarily kin to be spared, but potentially prey to be caught. Evidence of squid remains in giant squid stomachs has pointed to exactly this. There is a stark efficiency in the diet. The giant squid needs a great deal of food to fuel its explosive growth, and it takes what the deep offers, the fish and squid that share its twilight world caught by ambush and processed at the beak. It is not a fussy hunter. It is a hungry one driven by the relentless energy demands of a body racing toward enormous size. So the animal that legend cast as a devourer of ships is in reality a devourer of fish and squid, including sometimes its own. A predator of the deep, feeding on the deep's other predators, sustaining its furious growth on a diet of whatever swimming prey its long reach can seize in the dark. The monster eats monsters smaller than itself, and occasionally it eats its own kind. Turn now from the animal's biology to its long shadow in the human mind, where it lived for centuries before science ever caught it. It began as the kraken. In the old lore of the Nordic seas, the kraken was a colossal sea monster, a beast so vast it could be mistaken for an island rising from the deep to seize ships and drag sailors down into the water. Told and retold across generations of northern seafarers, the kraken loomed as one of the great monsters of maritime legend, a creature of enormous size and terrible menace lurking beneath the waves. And behind that legend almost certainly stood the giant squid. Its long limbs breaking the surface, its great bulk, its alien shape glimpsed by frightened sailors, these were the raw material from which the kraken was built. A real animal seen in fragments and in fear grew in the retelling into a ship-devouring monster. The myth exaggerated the malice and the scale, but its seed was a living creature in the deep. This is the giant squid's oldest role in human culture, the monster beneath the surface, the thing that legend placed at the bottom of the sea long before anyone could prove what it truly was. For centuries, the animal existed in the human imagination mainly as this fearsome shape, the kraken of story, standing in for a reality no one could yet reach. There is a long journey here, from the kraken to the creature we now know from an island-sized ship killer of legend to a soft-bodied, fast-growing, short-lived deep-sea predator that has never harmed a ship in its life. The reality is gentler than the myth and stranger, and in its own way more wonderful. But the myth came first. And it shaped how humanity met this animal for the better part of its history as a monster imagined long before it was ever understood. The legend was fed over the centuries by the bodies the sea occasionally gave up. Strandings kept the myth alive. Every so often, a giant squid washed ashore or was found floating a real, tangible monster, pale and enormous, delivered from the deep onto a beach or a deck. To people who had heard the tales of the kraken and the sea serpent, such a body was startling, confirmation proof that a genuine giant lurked in the ocean, that the monsters of legend had a basis in flesh. Each stranding was a jolt of reality into the world of myth. These beached and drifting bodies did double work through history. For science, they were specimens, the raw material from which the animal was studied and slowly understood. For the popular imagination, they were monsters made real dramatic evidence that fed the legend and kept the fascination burning. A giant squid on a beach was news, a spectacle, a marvel that drew crowds and headlines. There is a long tradition of this. Reports of enormous squid washing ashore stretch back through the centuries, each one stirring wonder and fear, each one seeming to confirm that the deep held creatures of extraordinary size. The strandings punctuated human history with periodic reminders that the monster was real, even as for most of that history, no one could say much more about it than that. So the giant squid sustained its legend not through living appearances, which were essentially never seen, but through its dead, the bodies that the ocean now and then cast up onto the edge of the human world. Each one arrived like a message from an unreachable place, a fragment of the deep laid out where people could finally touch it, and each one deepened the old fascination. The sense that out there in the dark water swam a genuine monster, of which this cold, pale, stranded giant was only the smallest glimpse. Many of those stranded giants found a final home where we could keep looking at them. They rest preserved in museums. In natural history, museums around the world, preserved giant squid are displayed whole specimens held in tanks of preservative or great models built to show the animal at full scale. These are, for most people, the only giant squid they will ever see, a real animal or a faithful recreation of one laid out where human eyes can finally take in its full size and strangeness at leisure. The museum is where the public meets the monster. There is real value in these preserved giants. A stranded or captured specimen, carefully kept, becomes a lasting scientific resource, a body that can be measured, studied, and returned to again and again long after the living animal is gone. And on display, it becomes something more, a way to bring the deep-sea monster into the daylight world. To let ordinary people stand before an animal that spends its life in a place none of them will ever go. To stand before one is to feel the scale that no number quite conveys. The great length of it, the enormous eyes, the reaching arms, the beak at the center, all of it laid out at arm's reach, an animal from the crushing dark, made suddenly quietly present in a bright and silent hall. The monster of legend rendered still and real, close enough to study for as long as you like. There is something poignant in these preserved giants too. Each one is a creature that lived its brief, furious life in the deep, was cast up or caught, and now hangs suspended forever in a museum's stillness, a single individual of an animal we can barely observe alive, kept for us to marvel at, long after its own short life has ended. In the hush of the museum, the giant squid finally holds still and lets us look our fill at the monster that eluded every glance for so long. That impulse to display it, to study it, to stand before it springs from something old and deep in us. Humanity has been fascinated by the giant squid for a very long time. The thread runs back through the centuries, from Aristotle, noting his great toothos in the ancient world, through the Nordic tales of the kraken, through the parade of strandings and the crowded shelves of proposed species, to the modern expeditions that finally filmed the animal alive. Across all that time, the giant squid has held a peculiar grip on the human imagination, a fascination that has never really faded. We have always wanted to know this animal. There is a reason it captivates so. The giant squid sits at the meeting point of the enormous, the mysterious, and the alien, a creature of monstrous size hidden in an unreachable realm built on a body plan utterly unlike our own. It is the closest thing the real world offers to the sea monsters of legend, and it turned out to be real. That combination, genuine monster, genuine mystery, is almost irresistible to a curious mind. The fascination has driven real achievement. It was this long human obsession that sent researchers lowering cameras into the deep for years on end, that funded the expeditions that celebrated the first photographs and the first footage as landmark events. Our hunger to know the giant squid is precisely what at last began to pull it out of the dark. The wonder did the work. And the fascination endures because the animal is not finished being mysterious. Even now, having glimpsed it alive, we still cannot say how many there are, where they breed, how deep they go. The giant squid remains what it has always been to us, a genuine monster of the deep, real and enormous, and still half unknown, holding our attention exactly because it has never fully surrendered its secrets. We keep looking because it keeps hiding. For all our fascination, one thing we have never managed is to keep one alive. No giant squid has survived in human captivity. Attempts to bring a living giant squid into an aquarium have failed. On the rare occasions when a live one has been captured or has come to the surface, it has not survived long. The animals simply cannot be kept alive in the conditions we are able to provide. There is no giant squid in any aquarium in the world, and there never has been. This is one monster that will not be held. The reasons trace to everything about the animal's deep sea life. It is built for cold, crushing, lightless water, for immense pressure near freezing temperatures, and a vast, dark realm that no tank can reproduce. Brought up into the warm, lit, low-pressure world of the surface, its finely tuned deep-sea body fails. The very adaptations that let it thrive in the deep make it impossible to sustain anywhere else. This sets the giant squid apart from so many other ocean creatures that people have learned to keep and display. Its smaller cousin, the more manageable squid, can sometimes be maintained, Even delicate deep-sea animals have occasionally been kept for a time. But the giant squid resists entirely. It belongs to the deep so completely that it cannot be moved from it and live. There is a strange dignity in that. In an age when humanity has captured, contained, and displayed so much of the natural world, the giant squid remains beyond our keeping an animal we can film and study and preserve in death, but never hold living in a tank for our convenience. It stays sovereign in its own dark realm, refusing the captivity that so many other creatures have not escaped. To see a giant squid alive, you must go to its world. It will not come to ours and stay. Set the animal now against the long backdrop of time, and its lineage stretches far into the planet's past. The giant squid belongs to an ancient line. Cephalopods, the group that includes squid, octopuses, cuttlefish, and their relatives, are an old branch of life with a fossil record reaching back hundreds of millions of years into the deep past of the oceans. Long before there were fish, as we know them before there were animals on land, the ancestors of the cephalopods were already swimming in ancient seas. The giant squid is a modern member of a very old story. This deep ancestry helps explain how alien the animal seems. The cephalopod body plan, the many limbs, the beak, the jet propulsion, the ring-shaped brain, the copper-blue blood represents an ancient and entirely separate solution to the problem of being an animal worked out over enormous spans of time on a branch of life far from our own. The giant squid is strange to us because its lineage and ours parted ways in the remote past and evolved in different directions ever since. The giant squid itself is a relatively recent expression of that ancient design, but the design is old, refined across an immense depth of time. When we look at this animal, we are looking at the outcome of one of evolution's longest experiments, a body plan that has persisted and diversified through age after age of the Earth's history. There is a humbling perspective in that. The giant squid is not a freak or an aberration, but the current form of a lineage far older than our own, a line of animals that was already ancient when our own ancestors were small and unremarkable creatures. In the deep dark, where it hunts, the giant squid carries forward a way of being alive that the oceans invented in a past so distant it strains the imagination and have carried unbroken all the way to now. The giant squid's sheer size fits a broader pattern of the deep one that biologists have long noticed. In the cold, dark animals tend to grow large. The phenomenon is called deep-sea gigantism, the tendency of certain animals living in the deep cold ocean to reach far greater sizes than their relatives in shallower, warmer waters. Across various groups, the deep-dwelling members run to giants, oversized versions of creatures that nearer the surface stay small. The giant squid, along with the colossal squid to the south, is among the most spectacular examples of this deep-sea trend toward the enormous. Scientists have proposed several reasons for the pattern, though it is not fully settled. The cold may slow growth, but extend lifespan and lead to larger ultimate size. The high pressure may play a role. The scarcity and patchiness of food in the deep may favor larger bodies that can travel farther, store more, and go longer between meals. Large size may simply be a good strategy for surviving the particular challenges of the cold, dark, food-poor deep. Researchers still debate which factors matter most. Whatever the precise causes, the giant squid stands as a striking case of the rule. It is a squid grown to extraordinary size in exactly the environment where deep-sea gigantism holds sway the cold, high-pressure, sparsely provisioned deep ocean. Its enormity is not an isolated freak, but part of a wider tendency of the deep to build things big. It places the animal in a larger story about how the deep ocean shapes life. The same realm that gave the giant squid its enormous eyes, its buoyant flesh, and its copper-blue blood also, it seems, drove it toward its tremendous size. One more way the deep has molded this animal to its own dark demands. The giant squid is a child of the deep in every dimension, including the sheer scale of it. In the cold and the dark, the ocean grows monsters. The giant squid is one of its masterworks. Return near the end to that startling genetic verdict because it holds a puzzle science has still not solved. Across every ocean on Earth, the giant squid appears to be a single species. The genetic study that gathered samples from around the world found them remarkably alike, so alike that the many proposed species collapsed into a single kind of giant squid inhabiting deep waters across the entire planet. From the Pacific to the Atlantic, from northern seas to southern, the giant squid seems to be one animal, one species spread across the globe. It was a profound simplification of a long and tangled question. But the answer opened a deeper puzzle. A single species spread across all the world's oceans with strikingly little genetic variation between distant populations. This is not what one would normally expect. Animals separated by whole oceans usually drift apart genetically over time. The giant squid somehow has not. Across enormous distances, its populations remain bound into one uniform whole. And scientists are still working to understand how. The leading suspicion, as noted earlier, points to the drifting young, the tiny paralarvae carried by ocean currents across vast distances, mixing the global population before the animals ever descend into the deep. Perhaps the currents themselves are the thread that stitches the worldwide giant squid into a single genetic fabric. But this remains a hypothesis, not a settled fact. The mechanism is still under study, so the one species finding is both an answer and a question. It resolved the old confusion of many proposed species into a clean single truth, and in doing so, it raised a new mystery about how such global unity is even possible. The giant squid turns out to be one animal worldwide, held together by forces we do not yet fully understand. It is a fitting discovery for this creature, an answer that characteristically arrives wrapped around a fresh unknown. And so, at the last, the giant squid resolves not into a set of answers, but into a set of open questions, the deep, unsolved mysteries that still surround it. Begin with the most basic. How many are there? No one knows. There is no reliable count of the giant squid, no confident estimate of its numbers anywhere in the world's oceans. The clues that exist, the beaks packed by the thousands into sperm whale stomachs, hint that the animals must be abundant, common enough to sustain a whole population of great whales that feed on them, and yet a living one is almost never seen. Abundant, apparently, yet very nearly invisible. That contradiction sits at the heart of the mystery. An animal common enough to feed the largest toothed predators on Earth, and elusive enough that photographing a single one alive was a landmark of the 21st century. Between those two facts lies an unknown population, uncounted and uncountable. With the tools, we have a number that remains simply blank. So, the most elementary question one can ask about any animal, how many of them are there, has no answer for the giant squid. We know they are out there in the deep, very likely in great numbers. We cannot say whether they number in the hundreds of thousands, the millions, or beyond. The animal keeps even its abundance a secret. And on that unknown number, the whole future of the species silently rests in a dark we have barely learned to look into. Ask the next great question, and the deep gives back the same silence. Where do they mate? No one has ever found the giant squid's breeding grounds. The mating has never been witnessed. The spawning has never been filmed. The places where these animals gather to reproduce have never been located anywhere in the vast deep. For the species to persist, they must come together, males and females meeting in the dark, sperm implanted, millions of eggs eventually released. It happens, constantly somewhere below. We have simply never found where. This is among the strangest of the animal's gaps because reproduction is the very center of its brief, furious life. Everything the giant squid does, the explosive growth, the relentless hunting, the enormous size, bends toward that single reproductive act. And that act, the pivot of the entire existence, unfolds in a place and a manner that has stayed completely hidden from us. The most important moment of the giant squid's life is the one we have never seen. Somewhere in the deep, at this very moment, giant squid are finding one another in the dark and carrying out the ancient business of their kind. We know it must be so. We do not know where or how, or at what depth or under what conditions they gather. The nursery of the giant squid and the meeting that fills it remain entirely beyond our reach. One of the last truly hidden chambers in the story of life on this planet, its door still closed against every light we have lowered into the black. There is a third question the deep will not yet answer, and it concerns the very floor of the animal's world. How deep does the giant squid truly go? The known range is only a sketch, the depths where dying animals rise, where whales dive to hunt, where the rare cameras have caught a living one. But the lower boundary of the giant squid's world has never been fixed. No one can say with confidence how deep these animals descend, how far down into the cold and the crushing dark their realm extends. The bottom edge of their range is a blank. The reason is the oldest one in this whole story. The deeper you search, the harder the searching becomes, and the animal has spent all of human history slipping past every method used to find it. The giant squid may range far deeper than we have yet observed into depths our instruments rarely reach, and our patience rarely lasts. We have glimpsed it in a band of the deep. We do not know the full extent of the darkness it calls home. So even the simple geography of the animal, how far down it lives, remains unmeasured. Somewhere beneath the depths where we have seen it, the giant squid may be hanging in water, blacker and colder and more crushing, still in a part of the ocean we have scarcely begun to explore. The floor of its world is unknown to us, waiting like so much of this animal. In a dark we have only started to enter. And there is the question that gathers all the others into one, the puzzle beneath the puzzles. Why does the giant squid grow so vast? We know that it does that from a hatchling on a fingertip it races in only about 5 years to the length of a school bus. We know it fits the broad pattern of deep-sea gigantism, the tendency of the cold, dark, food-poor deep to build its animals large. But the precise reasons remain debated. Is it the cold, the pressure, the scarcity of food, the pattern of predation from the whales above? Scientists still argue over which forces matter most and how they combine to drive this animal to such tremendous size. The honest answer is that we do not fully know why the giant squid becomes the giant it is. The question sits at the intersection of everything strange about the animal, its deep-sea home, its furious growth, its brief life, its place between the prey it hunts and the whale that hunts it. Somewhere in that web of pressures lies the reason for its size. We have not yet untangled it. It is a fitting mystery to hold near the close because it points at the deepest truth about this creature, that even now, having filmed it and named it, and read the rings inside its head, we still cannot fully explain the most obvious thing about it, its sheer staggering scale. The giant squid grew enormous in the dark, for reasons the dark has not yet surrendered. We stand before the size of it, and we still do not entirely understand what built it. Which leaves the final question, the one that reaches furthest and closes the whole story, not on an answer, but on the largest unknown of all. Is the giant squid truly one? The genetics said so. A single species spread across every ocean, remarkably alike, from the Pacific to the Atlantic to the southern seas, one animal wearing the mask of many. It was a stunning finding, and it resolved a century of confusion into a single clean truth. But it left behind a puzzle it could not solve. How a creature scattered across the entire planet could remain so genetically uniform, so bound together, so much a single thing across such impossible distances. The unity is real. The reason for it is not yet known. And so the giant squid ends where it began, as a mystery. For all that this century has finally shown us, the animal keeps its deepest secret still. We have counted the rings inside its head and read the beaks inside the whales, and drawn it at last into the light of a camera in the deep. We know its eyes and its hearts and its hidden blue blood, and yet we cannot say how many there are, or where they meet in the dark to make the next generation, or how deep their world descends, or why they grow so impossibly vast, or how they stay across all the oceans of the earth so strangely and stubbornly one. Somewhere below, right now in water no light has ever reached, the last great monster of the deep is hanging in the black, watching with the largest eyes on earth, growing toward a size we cannot explain, part of a single species we cannot fully account for, hunting, and hidden in a realm we have barely entered. It was a legend before it was an animal. It is an animal now, and it is still, in almost every way that matters, a question we have only begun to ask. The kraken was real all along. We just don't yet know how much of it we've truly seen. Good night.